Ja. Irgendwas an Geräuschen höre ich. Aber ich glaube, das ist das, wo du noch nicht hast gesagt. Ich glaube, da hängt einfach mal hinterher. Irgendwas an Geräuschen. Ja. Hä? Wieso? Ich höre mich selber nur, aber dich nicht. Nee, ich höre nur mich, glaube ich. Ich höre mich selber. Ja, tatsächlich. Ich höre im YouTube nur mich, aber nicht dich.
Es gibt immer wieder eine Rückkopplung.
Ja, aber nicht mit dem. Doch, leise höre ich einen Ton. Irgendeine Musik läuft da, also irgendeine Melodie läuft da. Doch, leise höre ich. Ja, vermutlich ist es die Musik im Raum, die ich höre. Es sind auch immer so Anflüge von der Rückkopplung im Ton, aber ich weiß nicht, ob das jetzt.
Ich glaube nur bei dir.
Es kann halt sein, dass es von mir kommt.
Ich habe nämlich. Ich habe hier keine
Okay,
Rückkopplung.
ist wohl nur bei mir. Sicher, dass man dich hört?
Die Frage ist das GEMA-freie Musik, die da läuft? Mob, von dir gibt es noch keinen Ton bis jetzt. Von dir gibt es bis jetzt keinen Ton im Stream. Das ist dir klar? Kein Ton. Ich höre den Christian und mich selbst.
Jetzt müsste es auch von mir Ton geben eigentlich. Kann man mich jetzt hören? Test, 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 Test. Test, Test, Test. Ja, bei YouTube hat er eine riesige Verzögerung. Es müsste jetzt gleich kommen. Man müsste mich jetzt gleich auch bei YouTube hören können. Jetzt müsste man mich auch bei YouTube hören können. Test, Test, Test. Man hört. Geht oder geht nicht? Okay. Super, gut. Okay. Ja, gut, super, danke. Ja, Briefkarte schon automatisch gemacht. Bestens. Okay. Okay, gut. Dann teste ich mal jetzt Ihre Slides kurz, ob das alles geht. Und würde wahrscheinlich auch noch mal den okay. Test, Test. Okay. Gut, das scheint soweit zu gehen, oder? Okay, gut, das geht auch bestens. Okay. Dann testen wir noch mal kurz die anderen Streams. Ja, aber jetzt müssen Sie sehen.
Cybersecurity is an amazing topic to study, and particularly it's an arms race between us and the attackers.
Building systems resilient to cyber attacks is of course a challenge of great practical interest.
Every day there's a new challenge to face.
Strong mathematics, but also a practical point of view.
Okay, guck mal jetzt noch. Es müsste jetzt eigentlich auf YouTube noch ein zweiter Livestream angegangen sein und auf Twitter und LinkedIn, auf Twitter und Facebook müssten auch die Streams jetzt laufen. Guck mal auf Facebook vielleicht, ob der da läuft. Genau, also auf Facebook müsste jetzt eigentlich auch der Livestream laufen. Wo ist mein Telefon eigentlich? Du hast mein Telefon, wo ist es hin? Bitte? Du hattest mein Telefon, du hast es mir wieder gegeben. Okay, ich hab's. Okay. Also es scheint bisher nicht online zu sein, würde ich sagen. Das ist jetzt auf diesem Restream. Ja, doch, aber es sieht, also hier sagt es eigentlich, dass es online wäre.
Ja, also irgendwie ist ein Bild online auf jeden Fall hier. Ach, das steht live auf jeden Fall, ja. Bei Facebook steht es wäre live.
Und live ist auch.
Also du, ist ein kleines Fenster mit dir und ein größeres, wo halt eben jetzt.
Ja, genau. Also das ist jetzt unser Image. Okay, das heißt, dann scheint jetzt und kommt da Ton. Test.
Der Ton läuft da, glaube ich.
Der Ton läuft da. Wo soll der herkommen?
Wo habe ich denn diesen Ton her? Vielleicht habe ich den von dem Zoom oder so.
Nee, den würden wir auch hören, wenn du Ton vom Zoom hättest.
Bitte?
Den würden wir auch hören, wenn du Ton vom Zoom hättest.
Den was?
Den würden wir auch hören hier.
Ich weiß nicht, wo der herkommt.
Wo kommt der her? Vielleicht ist irgendwo Musik laufen oder so im iTunes.
Eigentlich nicht, also es dürfte eigentlich nichts an sein. Sieht halt aus.
Test. Ah, ja, okay, er sieht gut aus, aber hat es Ton? Ja, er hat auch Ton. Okay, gut. Okay, er sieht gut aus. Okay, es scheint auch zu gehen.
Kannst du den?
Ja.
Ich muss mein Handy noch mal gucken.
Okay. Es ist irgendwie ultra laut im Vergleich zu dem Mikrofon, oder? Oder geht's? Es ist nur bei uns so laut, weil wir es nicht hören. Okay, vielleicht. Es geht. Okay, dann lassen wir es so. Weil also meines Erachtens ist es jetzt so, jetzt haben wir ein Setup, das funktioniert. Ich würde jetzt sagen, lassen wir so. Das, mein was? Ja, genau, weil er nicht an ist halt gerade, ja. Bonjour. Ouais, ça va. Ouais, ça a l'air de marcher maintenant. Oui.
Rede nochmal.
Test. Test. Es halt.
Auf dem Facebook halt es hintereinander. Test. Mach das jetzt mal weiter.
Echt?
Ja.
Aber wo kommt der Ton her?
Oh, jetzt? Ich habe hier mal so ein Delay. Deswegen kann
Ja, du hast einen krassen Delay, logischerweise, ja.
Jetzt ist besser.
Aha, naja, wahrscheinlich wird es gehen. Wahrscheinlich wird es gehen.
Geht nochmal.
Test, 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 Test. Test, 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 Test. Test, 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 Test. Test, 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 Test.
Ja, wenn
Test.
ich nicht hintereinander Test sage, dann weiß ich nicht, ob es ein Echo ist oder ob du das bist.
Ja. Gut, das muss man dann halt rausfinden, wo das herkommt, aber das ist jetzt halt so, würde ich sagen.
Ja, manchmal macht es auch nicht und manchmal macht es auch nicht.
Ja.
Geht auf dem Stream wieder raus, oder?
Aha. Okay.
Auf YouTube geht anscheinend ohne Hall und alles ist super.
Auf was? Auf YouTube.
Auf YouTube haben wir alle geschrieben.
Die Frage ist, wieso das andere einen Hall hat, aber gut. Okay. Okay, weißt du, wie jetzt das Programm ist? Weißt du, wie jetzt das Programm ist und wie viel Uhr was ist? Est-ce que quelqu'un sait quand et quelle présentation?
Ich kann es dir sagen, soll ich dir,
Oui.
es steht auch auf dem abgedateten Programm auf
Okay, dann sag's mir.
Also 13 Uhr Grand Opening, 13:15 IoT meets Security,
Mhm.
14:15 Business Values for IoT and AI, Niels Thompson.
Mhm.
15:30 Enhanced Company Resilience through Cybersecurity, Emmanuel Becker. 16:30 End-to-End Security for IoT Constrained Devices for Emmanuel Kuhn.
Okay, super.
Und dann gibt es, achso, um 15 Uhr gibt es einen Break, ne? Hatte ich das gesagt?
Ja.
15 Uhr ist ein Break, eine halbe Stunde, dann ist um 17:30 Uhr noch ein Break bis 18:30 Uhr, dass die stattfindet.
Aha. Okay.
Auf YouTube ist der Livestream jetzt zu Ende. Wenn ich das richtig sehe.
Nein, sollte eigentlich nicht sein. Je clique après A, c'est encore une fois le programme que vient de ça. Ok, on continue sur A, c'est ça.
Ok.
Et voilà.
Du coup, je passe sur Steam quand il n'y a rien à montrer, c'est ça?
Tu peux, si tu veux, quand il n'y a rien.
C'est
Ce sont les gens eux-mêmes. Parce qu'ils sont avec TeamViewer sur l'ordinateur qui est juste en bas.
D'accord, ok.
Et comme ça.
Ils ont le zoom pour leur tête et le team
Ouais,
pour les
exactement.
Ok.
C'est ça, c'est le setup. C'est un peu avancé, c'est pourquoi il ne marchait pas. Ok, ah oui, si on veut, on pourrait tester ça maintenant. Parce que quand on a 30 minutes de pause, on pourrait en effet.
Je ne vais pas commencer à 13h. C'est écrit 13h maintenant.
Oui, je veux commencer, mais sans Nicolas, je ne peux pas commencer.
Oui, d'accord.
C'est un peu le problème. Est-ce qu'on n'avait pas d'adapteur sur ça? Ah oui, on a. Ah oui, peut-être. Le 2, c'est quoi? Ah, le 2, c'est ça. OK. OK, donc si tu veux, tu peux essayer ici avec le disque dur ici. Donc on va lancer dans, j'espère, 5 minutes parce que Nicolas manque encore. OK. OK, si tu veux, tu peux me mettre aussi avec le son et l'image et me dire. OK. Et mettre les transparents. Mettre les transparents. C'est juste une autre scène. Ouais, OK. Il faut ton micro. OK, maintenant il faut nous. Okay, so a very warm welcome from our side to the third Future-IoT. We're really sorry about the IT problems we had this morning, but the sound was not working and everything was breaking. Unluckily, due to Corona, we could not enter the room yesterday to do a final rehearsal, so sorry for that. But now everything should work, all the streams should be working, and we are very happy to welcome you. So it's the third edition, as I just told you, and the two editions we had before were 2018 in Saint-Malo, where we had a great time. 2019, we had it in Munich. This year, we plan to have it in Strasbourg, but due to Corona, it was not possible. And therefore, next year, the plan is to have the on-site event in Strasbourg with all the challenges and updated keynotes and so on. So if you're interested, you're, of course, also very welcome to the event next year. To give you some impressions of the last years, because we cannot meet now. So this is how it looked like in Saint-Malo. So you see the nice church in the background with a very nice group there. And this is how it looked like in Munich. And if we would have been in Strasbourg, we would have made, of course, a very similar picture. We try to do everything to make it still a very good event for all of you. So who is participating? The problem is a little bit in these distant presentations, how to bond. Therefore, we have different elements that will help you to do that. And for those participating in the Zoom, it's a good idea when you start your camera so that the others can see that there are also faces behind the names. The bandwidth should not be an issue, so you can start it and it should be fine. And yeah, so you're highly welcome to do so. It will make it much more fun to be virtually together. So who is participating? So we have over 300 people registered in the stream, which is great. And I hope that we might even get some more because you can, of course, spread the good news. So I put you some statistics from the registrations. We had planned to have nice t-shirts. So I have the t-shirt from last year on, for instance. So it's this one. And for this year, we also would have had similar t-shirts, of course, with this year's logo. And as it was still till the last moment not clear if we have to go virtual or if we can stay online, we also did the poll, which t-shirts you want. And from the poll, we see that the majority chose a male shape. So probably we have more male participants than female participants. The circle in the middle shows you the color choice. I put this one because it shows that we have different tastes, we like different colors. This is very good. And the one on top, shows your experience with the IoT, and we see that it's mixed. Could you give me the water, someone behind you? Thanks. Okay, so we are in cyberspace. That means you have to get active to make it really an active event. And therefore, please talk about the event wherever you can. Use the hashtag FIoT for Future-IoT 20. And thank you very much, Nicola. And follow and like our streams in the social media. We have the different channels that I put here. We'll put you also the slides online. For each talk, we'll have the continuous stream. So the one the YouTubers are probably watching right now. Plus we have on different YouTube channels, on multiple ones, we also have streams per event that you can easily share afterwards. Plus we have streamings on Twitter and we have streamings on Facebook. So please interact on all platforms. We have the nice chat tool that we can interact with you, and we highly welcome your interactions through the chat, because this is what will make the event lively. Okay, so yeah, inform your friends. This is what I wrote here. I have to get a little bit closer because we only have a small screen here. For the Zoom users, what did we implement to build the groups? Well, we have different elements. Maybe Leo switch to the smaller camera image so that, yeah. Okay, so please open the camera. I already said that. After each keynote, we'll use the breakouts. So you'll have 5 minutes in the breakout room where you can discuss with random people you were put together with from the Zoom conference, how you like the talk, which are the questions you want to ask, and afterwards we'll do the Q&A. We have 3 poster presentations. Who did not yet send a poster, please do so until tonight so that we can include them. The poster presentations will be a pitch. You will have 2 minutes in the auditorium, so the thing we are currently in, to pitch your poster. We will create a slideshow on it. And then afterwards, we have a very nice tooling that you see here on the bottom. And there you can watch the posters, visit them, and talk to the other people. Erkin, if you are there, you could take over for a minute and talk about the tools that we use for the poster presentation. Is Erkin in the chat? Okay, seems not to be the case. So if he would be there, just open your microphone and you can do it. As long as he's not there, I will talk about it. So this is the tool. And
can you hear me?
Yeah, now we can hear you. Perfect.
Okay, sorry, I was muted. Yeah. Okay, so this is a screencast you can see that we will use for poster sessions. So after your pitches, which will take 1-2 minutes after you introduce yourself, we will meeting here. The trick here is we have maximum 25 number of participants that can be here. You can see, for example, Professor Mob is walking right now in the room, and these are different presentations, different posters. You can also see my nickname is Napoleon. One poster you can see. So what we will do here is, it's just we imitate normal poster session in the conferences. You can walk around the posters, and then you can talk about the owner, what's going on there, what is the trick there, etc. The thing is, the capacity is 25. So after the pitch, please, be quick to get a seat. First come, first serve. I will make sure that the poster owners will be in the room. But for the free slots, whoever can get can join the room. I hope it will be fun, and then we will use this tomorrow and on Wednesday after poster sessions. That's it from my side, Professor Paul.
Perfect. Thank you very much. And so this is a very nice tool. What I especially like about it is that when you approach people, you only hear them when you're close to them. And it really gives kind of the feeling that we would have in a poster presentation session. Okay. For the free streamers over YouTube, so you can still upgrade over the website if you want to be in the Zoom, of course. Besides that, use the chat actively. Also chat with each other over the chat in the YouTubes and in the Facebook and the Twitter. We will bring your questions in after the talks. As we will do the 5 minutes break after the talk, you also have 5 minutes to write down your questions, and then we will select some of them and bring them in to the chat afterwards. And as said before, a lively discussion will make the event a big success. Okay, so I think there was some remote clicking. I just updated the program, but it's still the old one. Okay, so we are scheduled a little bit backwards. So we started at 1. So I'm really perplexed that it's not the updated one. And also that it's continuing to click through. Okay. Yeah, so we started now at 1, and we'll have the, Olivia, when is the next presentation? 2:15. Okay, we'll have Niels Thompson at 2:15. Then we'll have the break at 3. And we'll then have Emmanuel at 3:30, and we'll have Paul Emmanuel at 4:30. Okay, so this is the plan for today. Good. Tomorrow, we start at 9. We start with a talk about culture of innovation. So I'll not go into detail with the talks now because we're a little bit behind. Afterwards, we have the first poster presentation. Then we have another talk. Then we have a longer lunch break. Then afterwards, we have 2 talks. And then we have another break. And yeah, let's switch back once again. So tonight, because we cannot physically be in Strasbourg, we have a special event. So Nicola and friends will do a virtual city tour to Strasbourg, and I'm really looking forward to that. Tomorrow, we have an interview with Windsurf, and afterwards, Nicola, I, and some friends from here will do a panel, discuss with you about the internet architecture, cybersecurity, and so on. And on Wednesday, which is our last day, we start with a poster presentation in the morning. Then we have a break, and then we have a keynote, another poster presentation. And in the evening, we have a talk by Martin Hellmann about ethical decisions in computer science, which is also a very important topic that is strongly linked with cybersecurity. And afterwards, also a panel on that. Yeah, so the streams features a full program from 9 to 20 usually. In the bottom, you see the setup. If you're interested, write it in the comments. Then I can also detail you what is our setup and why it was so painful to get it running. Yeah, interaction is the key. And that brings me to the partners. So we have different partners here that are supporting us. And I don't know why it was closing. And one important partner is the German-French Academy for the Industry of the Future that is collaborating us is joining us from early on. And yeah, therefore, I want to mention them. So, Nicola, maybe you also want to give some welcome words, of course.
Should I switch on my mic?
Yes. It should work.
Yeah. Mm-hmm. Where's the camera? Okay. Okay, hello, my name is Nicolas Montavon. I'm the co-organizer with Marc Oliver, and we are very pleased to welcome you on board. We hope you will enjoy the week. Yes, we are very disappointed that we cannot meet in Strasbourg. We wanted to make it until the very last moment, but it appears that the situation was very bad and is very bad. So we try to make the best we can to have a great event anyway. So I hope that everything is going to be fine and that we'll be able to actually talk together, interact together, because I agree with Marc Oliver, it's the most important part. Well, do you want me to go over the sponsors or?
Well, I don't think we have to do that,
okay,
because we will see them with each of the talks.
Yeah.
So the companies at the bottom are the ones that give the keynotes, and the ones on top of the organizing organizations and funding sponsors and so on.
Yeah, we are very happy to have a lot of industrial partners that supported the school and wanted to participate by giving talks. And we were supposed to organize a project with them working on their hardware. So that was definitely a very interesting part that we have to skip because yes, we don't meet. Well.
And the reason why we skipped it is especially because this is really a hands-on experience. It's about sitting together and doing something together, and it didn't make sense to us to do that remotely. Mm-hmm. And therefore, if you want to have that, join next year again. Okay, so yeah, I think that was it. A
Thanks.
very warm welcome from our side. Leo, maybe show the still for a second in the stream, because then I switch the presentation and then we directly. Yes. Okay, perfect. And then please the slides, because we have the trailer at the start. Okay.
Cybersecurity is an amazing topic to study, and particularly it's an arms race between us and the attackers.
Building systems resilient to cyber attacks is of course a challenge of great practical interest.
Every day is a new challenge to face.
Strong mathematics, but also a practical point of view. You need both.
Help giving users a more secure experience.
It's like a game because you have two sides, the defender and the attacker.
It is a wide domain. We often necessitate knowledge from other areas, in my case, industrial system and machine learning.
The domain is complex, and it requires the understanding of heterogeneous data sources and use cases.
And the new things to learn.
So cybersecurity is just very motivating for me, because in cybersecurity you may have some prior knowledge on the nominal behavior of your system, but you have to face attacks that are yet unknown.
Okay, so yeah, as I said before, my name is Mark Oliver Pahl, and I'm not only running the summer school, but I'm also the chairholder of the Chair Cyber CNI where we do cybersecurity research, and there are also some people in the audience today that were also in the video and saw it for the first time, I guess. Okay, so with this talk, I want to set the stage, and let's start with critical infrastructures, or with infrastructures that can be attacked. So what are these infrastructures? I put you some examples here. So you see healthcare, water supply, energy supply, communication, data centers, industry 4.0, transport, defense and national security, finance, education, research and innovation, food, and many more. Why did I put exactly these? Because you see cyber-physical systems, systems that are computers connected to each other, doing something together, or even being connected to the outside world, are ubiquitous. They're everywhere. They're in the middle of our society, and they're also especially connected to the internet. And this can lead to problems, because in the internet, they're not only good people like you and me, but they're also bad people. I symbolize them here in black. And these bad people that are distributed all over the internet can attack the resources in these systems comfortably from their home. And when they attack these systems here, then they do not only attack the systems, but they attack our society, because they attack your water supply, they attack your energy supply, and this is, of course, nothing that you want. And therefore, at the chair, we work on how can we protect against this, and we have different directions we look at. So we look at prevent. So we try to prevent attacks as much as possible. This is so-called security by design. That means we develop mechanisms to protect systems in the best way possible. Now you might say, okay, if you protect the systems in the best way possible, why do you need something else? The answer is you can never protect a system 100% if the system is a system that is flexibly interacting with its environment, because you have programs that change over time. You bring in new devices, you remove devices, you change configurations, you have humans interacting. So you have dynamics that you cannot get rid of, and you also don't want to get rid of, because this is exactly the functionality that you want to have. And therefore, the second thing that we're doing is detection. So we look at how can we detect attacks or anomalous behavior of such systems. And when we detect such a thing, then we look at, okay, how can we mitigate from these attacks? How can we have automated defense? How can we bring the user into the loop so that the user is getting the information that he needs in order to understand the system better? So this is what you see with the lights here on the right side. For doing this protection, we use multiple mechanisms. I put you some examples here. So we use also machine learning to do fuzzy data analysis. We use so-called digital twins, so digital equivalents of a physical something to do tests and also to check and understand the systems. We use distributed ledgers to exchange information between untrusted parties. And we also look at ethical algorithms. So how can we design systems, computer programs in a way that they behave ethically? And this is exactly what we will discuss on Wednesday in the last evening session, where Martin Hellman, a Turing Award winner, so this is one half of the Diffie-Hellman key exchange, he will talk to us over the recording and tell us why it's so important to always take such ethical decisions. Okay, now you know a little bit the stage. Let's dive a little bit deeper. So this thing we're talking about is also your smartphone. This is also a cyber-physical system, so something that you carry with you. It's safe-driving cars, like the one here. So now the car is driving, and you see that the car is processing its environment, it's collecting data, it's reacting to the environment. If someone hacks it, it might crash into you. If it's a self-driving car, and this is of course something that you don't want to have. And therefore, security is super important in all the environments I was talking about. and especially also in the Industry 4.0 setting. And here's an example for such an industrial robot as you find it in an Industry 4.0 factory. And I chose this example because it shows you why malfunctions could harm you, because let's see what these guys are currently creating. Yeah, so I fast forward, so this is the end. And so this robot controlled chainsaw was building two stools and a table, which is of course nice, but now imagine you work with this machine, you're there where the people are right now, and a hacker attacked the machine and is now moving it towards your head. This is obviously nothing you want. Okay, so let's come to the challenges once again. So this is a workshop as you found it at the beginning of the 20th century. What is important for me here is that you have many people, so these here, so I have lots of them, and you have machines that are doing a job there and they're isolated, and people are taking the goods and carrying them from one post to another. This is what characterizes the industry. Also at the beginning of the 21st century, it was more automation. But the key aspect here is you have isolated systems that are interacting with the humans, and you do not have full automation. When we switch now to a modern workshop, which is this one, you see that there's at the moment an industrial robot coming. There is way less people, as you see here in the back. And what is important here, that everything is networked. So you have distributed sensors and actuators, and they're all connected and also connected to computer programs and doing something there. And this is a big paradigm shift. So let's have a look at why. So this is now a modern factory. So you see at the bottom that you have the machines that interact with you and interact with the humans. And on top of that, you have the controllers here. And on the right side, you have the network. Okay, so that means inside the factory, everything is connected. Good, but it doesn't stay inside the factory. Typically, the factory is also connected to the so-called cloud, where you have servers, and then more recent paradigm is the edge, where you have also servers that are used for broader areas, but are closer to you, which is from a security perspective good, from a latency perspective as well. So what is the problem now? You don't only have one factory, you have multiple factories. They are connected over this internet, which is good because we exactly want to have the services that are offered through this connection. But the problem is, when you look at the attack surface, at the beginning, when everything was isolated, you had so-called insider attacks. So people inside the factory could do attacks. Of course, you don't want that. But if you have a good company culture, or if there are not many of them, you can limit this. You can also do physical access control and similar things. When we go to the edge fog, the setting is changing. So there are already more people because it's more attractive and it's also closer to the internet to do attacks there. And when we then finally go to the internet, then we see, okay, there are lots of attackers simply for the rules of statistics. So they are just more humans, and they are capable of attacking, as I said at the beginning. So what are the security problems now? I put you 3 examples. So the first one I simply call security. And what is this about? Well, this is about you have your factory, and then someone is attacking the factory, and then your production is not working, your factory is stopping, you're losing money. Of course, this is nothing you want. The second, to me more important, safety. So you have human workers, and these human workers are interacting with the robots. And as we've seen with the robot arm controlled chainsaw before, this bears of course a risk, and therefore you have to take care of that. And the last point I put here is privacy, because we've seen before cameras. So this is again something that these IoT systems by design have to interact with the environment, because you want to have context-sensitive services. You want to have services that react to what is happening around them, and therefore they have to collect data. But of course, you do not want everybody to know when you go to work, what exactly you do, see your image when they want to remotely access you, and so on. Therefore, privacy super important as well. Okay, so now we have a little bit abstract attacks. I bring you now 4 example attacks, and then Lars will detail to you the first one I come to, you definitely heard of. So it's the Stuxnet attack. And I will not go into detail to these attacks now, but as said, you have the slides afterwards. On the right side, you see some of the interesting questions, and you also have some starting links. So this is something to look at, an important and interesting cyber attack. The second one I want to mention is the flame attack. Here you can also have a look. The third one is the so-called HAVEX attack. Also an overview on that. And the fourth one I want to mention and give you the hint to look at it when you're interested at home is the black energy attack that is given here. And that said, I hand over to Lars, who will take you through the more details of the Stuxnet attack. Lars.
Thank you very much. I hope that. So I guess, yes, most of you will have heard of Stuxnet before. It's a malware, or, well, the first malware discovered. I'm not sure. I cannot press forward.
You cannot, maybe you have to click again on the image. If not, I can press it. You can just tell me.
Yes, please go ahead. Yes, so it's a very rather sophisticated malware, and the first digital cyber weapon that was actually used to attack some physical infrastructure. In this case, this was the Iranian nuclear program, and it was then uncovered in 2010 when it broke wild because the creators made some mistakes in the spreading mechanism they used, and then it went almost everywhere or infected many systems. I'm not sure if you used the computer back in the day, then your antivirus software might have found it after it was uncovered. It was initially built so it spread over the network, but it ultimately compromised the programming logic controllers in the enrichment side and manipulated the behavior to break different centrifuge. How that was done, we will get to later. Yes, but well, it was highly tailored at specifically this enrichment plants in Iran. And as you can see in the picture here, you can see that there's almost no doubt that Iran was the target of this attack. After it was uncovered, it was extremely well studied. I guess nowadays you cannot read any paper on security of cyber physical systems without stumbling upon Stuxnet. There's an extensive technical report by Symantec. Goes very much into the details of what or how the malware worked. And then there's also a book by Kim Setter, who did the geopolitical assessment of Stuxnet, who might have been the actors or who probably was the actor, and working on that, and then created the malware. So on the next slide, we will see the path that was taken to breaking, well, lots of the centrifuges that are used to enrich the uranium for nuclear, to develop nuclear weapons. There, well, the layers that we all know, the IT layer, on which, well, we have the network itself, operating systems and different applications running on the computers. And well, the first goal, of course, is, well, to infect these computers, which then can distribute further. Well, basically the goal is to get onto the PLCs and manipulate the routine such that the centrifuges will break. A very, very important aspect of Stuxnet was that it was deeply undercover. So a main emphasis on the development or on the functionality was that it remained undetected. And well, once we are on the target machine, we can concentrate on getting ahead onto the ICS layer, or well, where the industrial controllers are, or the subcontrollers controlling different valves. And there we want to manipulate the control such that other commands are sent or executed than intended to damage that on the physical layer where the devices themselves are. And yes, ultimately our goal was, or the goal was to break it. So first step from the next slide is the infection of the machine. So Stuxnet targeted specific 32-bit Windows versions. There's a control flow where it just went onto the machine, then checked the bit, the operating type, the architecture. Well, in case it did not have any administrator privileges, it did some privileged escalation and then continue. And then this was one of the first very interesting is that it checked for the running processes, amongst which the running antivirus software, and it would hide differently and behave differently depending on the software that was installed on a computer to remain undetected. After that, it ran the DLL, so it was all delivered in a DLL. And after it started to check for internet connectivity, and if there was internet, well, it connected to a specific command control server with some specific domains to send information about the system it is on and receive also commands from remote. The interesting thing there, it had also some peer-to-peer capabilities. So it also checked the network for other computers, first to infect it, but also to update itself in case it did not have the newest version. And yes, so the goal after establishing itself on the machine as well, just infect other computers, which is on the next slide then. So we want to propagate through the network. Well, first of all, as I mentioned, we have some peer-to-peer communication where we could update others or get ourselves updated, infecting special computers with control software. So when CC machines there, they often had a hard-coded password in it, which was publicly known. And it infected network shares. So everything there. There were 2 0 days that were used. So first through a print spooler, which was, well, it was a 0 day, which was not patched, but it was publicly known before. And then a unknown service, so in the Windows Server service. And later, the latest, so most of the time, in order to infect air-gapped systems, it could also install itself on or hide on USB sticks and get there and then propagate through USB sticks. There, it was very interesting that this phase had a timer on it, so it only ran through for a couple of weeks before uninstalling itself if it was unsuccessful or receiving a special command. And also on the USB drives, it infected, it had a counter in it counting to 3, so it would only install 3 times or infect 3 machines. What is very interesting about that as well, so the propagation methods changed throughout the different versions of Stuxnet. So at the beginning, it was limited to the removable drives and the peer-to-peer functionality in the Windows Server and principal. and the network shares were not affected in the first versions and only were added later on in later versions in which it then has gotten out of hands. So yeah, so now the next step is when we have infected ourselves and we are on the computer and do so we want to get onto the next layer, so the ICS layer. And that's on the next slide where we have the manipulating of the industrial controls themselves. So Stuxnet targeted a specific version of the Siemens industrial software for industrial controllers called Step 7. And therefore it skimmed through the file system and looked for to the installed programs and looked for specific installations of Step 7 and infected very certain or specific project files. So as before, it is a highly tailored malware that was only targeting these enrichment plans. So it installed itself there and manipulated different project files to modify the logic on the PLC itself in case they are connected. It went even that far that it reprogrammed or self-written basic functionality for PLCs that are usually default on board, and even despite still hiding itself. So Stuxnet was also the first version of a rootkit for program PLCs. And so then once we are on the PLC, of course, we also want to do our thing, yeah. And Stuxnet had a very specific way of working. So if we continue on the next slide, we have a state machine of the attack, and initially we are in state 0, where we wait for a few hours, and then are installed or start executing. And after a few, if we're in that state, Stuxnet still remained silent. It just listened in the network and on the PLC looking for actions, what was going on, and collected this data for use for later on. After it collected enough data, I mean, this could be any amount of time between 13 days or 3 months, depending how active or how much activity was on there. And then it went to the next day, waited for 2 hours and did nothing, waiting for another. So collecting or reassembling that to mimic the behavior of the PLC for later on, during the time frame in which it actually manipulated the valves and centrifuge. And in the next stage so we're now in the third state, the rotation speed of the centrifuges was accelerated. The valves were closed a little to increase the pressure within that keep the gas or in the centrifuges in a certain state to make this gas also unusable. And then after 15 minutes, just go back to normal. And this time, the commands were sent to the centrifuges from the PLC, and the output from the centrifuges was also monitored. However, the output was also overwritten such that it appeared for the operators of the plant that nothing would happen, and the operation was quite normal. Also, the changes were very, very tiny, so they were looking for specific frequencies for the centrifuge to operate on, which were damaging. And after a while, so since there were lots of tests by the IAEA, so the atomic agency supervising the nuclear program in Iran, the auditors began noticing that lots of centrifuges were breaking. And first of all, this was a very tiny amount of centrifuges breaking, but these checks were done every 3 months. And more centrifuges kept breaking at a very unusual rate. So there, first of all, it was said that there are some malfunctions and they tried to cover it up. But after a while, it became clear that there's something wrong and they were trying to find the root cause. And at the beginning, it appeared that there was no root cause that could be found, but it continued to break. And after a while, Symantec went public to announce that they have found Stuxnet, because apparently the versions had changed again, and it spread wildly to lots of machines that were not intended to have it. And that's when the Iranian government found out that Stuxnet was actually targeting their nuclear program. Well, after this, we're on the fourth state, where everything went back to normal, and then Stuxnet went back to being quiet and waiting for another, and going to state 0 again. Yes, if you want to read more about that, I've put some references on the side there. So these are some extensive reports. If you're very interested in that, there's a lot to learn from that. So, thank you very much. Thank you for listening, and take it away.
Is it working again? Okay, perfect. Yeah, sorry, I think it was a battery problem with the microphone. Yeah, so thank you very much, Lars, and you can already note down the questions for him, because I'm sure there are more questions, and I can highly invite you to study such attacks, because you learn a lot about the systems that are getting attacked. Okay, so yeah, this brings us to the defense side. So what can we do against such attacks? So I said it at the beginning already, we can do security by design, securing the systems as much as possible, starting from the users, going down to the physical protection. Then on top of that, we can do automated monitoring and defense. So looking at if something strange is happening here, machine learning can help us, for instance. And then on top of that, we have to have the human in the loop, because security is nothing clear in the sense, okay, this is exactly how security has to be done, but it's something that grows with the policies that the users want to have in the systems they want to secure. At the chair, we of course cover all these topics. So I told you already, prevent is important, and you see in the animation on top with the attackers that they are getting less through the activities that we do. So prevention protects against lots of attackers already. Detection helps us to understand the systems, and then the automated defenses. This is something that is helping to minimize the attack risk. So now I brought you once again some of the members of my chair telling you what they are at the moment working on.
Industrial systems.
Formalization of resilient systems.
Security risk optimization for learning on heterogeneous quality data.
Management of access control in IoT infrastructure.
Safety and security.
Threat analysis.
Diagnose incidents.
Enhance situational awareness of cyber analysts.
Random distortion testing, RDT in short.
Traceability and integrity of information.
Platforms for research purposes.
Values from sensors, actuators, and automata.
Detection of anomalies.
NFV, which is network function virtualization.
Critical systems.
Risk analysis methods based on extension of attack graphs.
Anomaly detection in physical data from the secure routed treatment testbed SWAT.
Network intrusion detection system.
Access control policies on IoTs.
Machine learning to design ideas.
Okay, so you see there's a broad range of activities, and on this slide here, I brought you some of the topics we're currently working on. I will not go into detail, but as you see, it goes from the prevention side to the user interface side, where we have some 3D interfaces. And to come to the end of the presentation, I brought you some videos from the infrastructure that we are running at the chair, because we have quite nice test beds for doing our security research. And I will just start the videos. So here on top, you see some Fisher Technic factory emulators. These are tiny factories that are controlled by the real PLCs, by the so-called programmable logic controllers, the things that were attacked in last scenario. And here we have a factory. We can look at what happens when there are some attacks. How can things be changed? What are the effects of changing something physically, and so on. And as we have the real PLCs, we can really look at the attacks and do not only have something that is simulated, but we have the physical interfaces that you also have in a real factory, like with the robots we've seen before. Then the second point, this is another version of it. We also look at electrical signals, as you see here. This here is a very similar approach, but here the effects are purely simulated. So here we see a cream factory. Again, the control comes through these industrial controllers. Of course, we also do simulation internet measurements. For that one, we have servers. Then we have real heating devices here, where we can do changes. And this is a heating circle. Oh no, it's not. So this is a motor, and next to it is a heating circle. So here we have a motor where we can do changes. This is a real heating circuit where we can change configurations. Here you see the water tanks, and you see the actual heater. So the camera goes there now here. This one here is a test bench for these industrial controllers. Here you see the virtual reality interface we're working on. And here in REN, we also have a fab lab where you can do 3D printing and similar things. So this is quite cool. And yeah, this is a little bit the REN campus here. Okay, so now you get an idea what we're doing. We have now a footer where you also see an animation where we currently are, because we are physically in REN. You see the map where this is. And then afterwards, we will put you into the breakouts for 5 minutes. And I will tell you again in a second. You can already start thinking about your questions, or if not, you can enjoy the ending video of this presentation. Okay, so yeah, thank you very much for the attention in the keynote. So now we will put you into the breakout rooms. I don't know, Lars, if you have the control for the breakout rooms. Okay, you don't, then I will do that. And so the idea is now you get into the breakout room with as many participants we have divided. I think I will put about 3-4 people per breakout room and discuss a bit what are your questions about the talk and think about what you want to ask afterwards. And those of you following in YouTube, just write your questions because we'll also come back to your questions there. Let me just go to the Zoom meeting so that I can put you into the breakouts. I just have to get rid of this. Stop sharing. Exactly. And let's do that. So we have how many people in this stream at the moment? Let me just, okay, 35. That means we can put it into about 10 breakout rooms. Oh yeah, so this is, it's even showing me. Okay, assign automatically and create. Okay, and so you will have 5 minutes and afterwards we will see a timer and then you will automatically come back and then we come to the questions and you can just unmute your, then yeah, we'll moderate the questions and the mode is if you have a question, raise your hand, which you can do in Zoom when you're at the bottom and then we'll call you. Okay. Or let's do it otherwise. Write the question into the chat and then we'll call you and then you can ask the question. Okay, so I hope everything is clear. Then I put you into the rooms and take you back in 5 minutes. Okay, very good. Okay, so I just closed the breakout rooms, so it takes 24 more seconds. So we already saw that there are questions in the social media, and Nicola will be our moderator for the Q&A session. And Lars and I will be very happy to answer you. Okay, everybody is back. Wonderful. So the mode is now, if you have a question, raise your hand in the chat, and then Nicola will call you. The chats from the YouTube, Twitter, and so on, who feels responsible of telling them this person, is Christian there? Is Ekin there?
I can do it.
Okay,
I'll
you can
just
ask yourself then.
forward them.
So just raise your hand. Just raise your hand then in the chat so that you also have a question so that Nicolas knows. Okay, then we can start. Nicola.
Don't have question.
So while we're waiting, I do have a question that I would like to forward to you because I have received that earlier on. So in the slides you said that there are lots of security and safety things that have to be considered. And then you also mentioned these along with security by design. How do you think of all the things in the first place, and how do you incorporate that into the design?
So thank you very much for this very good question. So how do you incorporate it into the design? So this is an interesting question in that sense that the design is a huge process. So it's not just one step, but you have to introduce it from the beginning, where you think about what you want to do with your product, which is, for instance, when you think about privacy, which is the information that you will collect, why do you want to collect it, which is the principle of least data sharing, least data storing, least data processing. Then, of course, when it comes to the algorithms and the software that you're running, then a super important thing is applying security standards in the right way. So in the right way is the challenging thing here, because you have complex systems with different components that interact, and you have to create then the links in between the system parts that they are secured and so on. So this, and it does not end there. So it's also running the program later. So it's throughout the entire life cycle, and it's through a bunch of different questions that are important to take into consideration. Okay, so I don't know, do we have something else from the chat? Because if not, I'm also not unhappy, because then we can switch to Niels.
Yeah, actually, I have two questions here that were written, so I can read them for you if you want. So the first one is, what are the major reasons for IoT security breaches? Which layer is the most vulnerable?
So I would say the major reasons why IoT is so vulnerable is the distributedness of the systems, which introduces complexity. So you have to take into consideration when a part of your system here is broken, the entire system is broken. And the second major point I would mention is heterogeneity, because you have lots of heterogeneous devices that you bring in, and the weakest part of the chain is defining the security that you have. So this will be my quick answer to that.
I have another one. It's about the Iranian facility. So the question is, did the Iranian facility have some security measures in place which the authors of the malware had to overcome, or they relied mostly on the internet air gap?
So I hand over to my Stuxnet expert, Lars.
So there's a combination of both. Of course, they had the air gap things, and so the creators of Stuxnet got very lucky because in order to create such a tailored malware, you have to have a lot of knowledge of the system, and they got lucky and intercepted some of the devices, and they kind of built a replica of the plant by themselves, for themselves, and then developed the malware. And yes, they had to overcome also security. As mentioned, they actively hid their files or their activity from the antivirus software. There was also AV software, which Stuxnet was not compatible with. So in case it was found this thing, then it would uninstall itself immediately again. I hope this answers the question.
Mm-hmm. Very good. Thank you very much. Yeah, and so this probably concludes. There's one more question, yes.
Yes, one more. What is a resilient system, and how is it different from any other information system, and the need to make all IS resilient? Is it IoT specific term?
Yeah, and so my answer to that is, of course, it's not an IoT specific term. So resilience basically means that you build a system that even under attacks and unforeseen situations, the system is still delivering its service. And this is what resilience is. And again, for the IoT, it's an even bigger challenge than for other systems because of the heterogeneity and distributedness that has resource limitations and so on. Okay, perfect. Good. Then thank you very much. Thank you very much, Nicola. Then we go to the next stream. Leo, this one you can keep running, but you can go to the, you can also leave me, it's fine. But you have to just stop and start in the OBS and switch the input source to the one that is not selected. The one. Perfect. Okay, good. Then it's my greatest honor and pleasure to welcome today Niels Thompson of Atos. And Niels is the Group Vice President, Global Head of the Inside IoT and AI practice and Head of Global Business Development for Managed IoT at Atos. He has more than 25 years of cross-industry experience in large international companies. Niels joined Atos in 2012. He's married and he lives with his family in Munich. Niels, sorry for the delay. It was really not possible because it was not working, but we're all looking forward to your talk and I hand over directly to you. So you can unmute here and I hope you have control. Perfect, thank you very much.
Yeah, my control does not work, but I hope Lars will help me. So thank you for inviting and no worries, I'm happy to be here and to give a presentation. I hope I come over clearly.
Yeah, we can hear you clearly. It's working perfect. Yes.
Okay, great. So if I may ask you, Lars, to ensure that we can share the presentation.
So it is shared now on the screen or on the stream.
Okay, thank you very much. So first of all, welcome you all, and thank you for inviting me to be here with you and to go a little bit through you within IoT and AI and how we in Atos try here to drive business value out of those subjects. First of all, I want to tell you a little bit about who Atos is. If you move one slide forward, then we will go through the business value. We will look into how we drive it, and how we see this moving on in the future. Let's go for slide 3. Atos today is 110,000 people. We emerged together over a lot of companies over the last couple of years, and we are today one of the top 5 digital service companies of the world. We have a clear vision and mission on really reducing CO2, so increasing decarbonization, and we have officially committed ourselves to follow the goal of the Paris meeting on decarbonization. So we want to not get to neutral, but really get to 0 in 2035, and we want to also move our clients there. We are also one of the leading companies within cybersecurity, and as you can see, we spend well above 200 million every year in R&D. If you move to slide 4. So just to tell you why we are talking about IoT and AI today. The market analysts are clearly seeing Atos with our Codex brand to be one of the leading companies within IoT and analytics as a combined solution. They have seen us in that upper right-hand corner of the Magic Quadrant for 3 years in a row now, and being one of the few companies that actually can deliver this as a service, not only as a project, but actually scale and deliver this as a service, which is one of the core KPIs to be able to deliver value out of the solutions. If you move to slide number 5. So as I told you, Atos wants to really focus on decarbonization, and we have announced our commitment to net zero by 2035. And IoT AI is going to be one of the key parameters to actually deliver this. We already reached carbon neutral in 2018. So this is a really next big step for us. And as I said, the combination of IoT, analytics, AI is going to help us to reach that goal. Now, let's go into a little bit more of the topic today if you go to slide 6. With slide 6, we now enter into the part of the section around value through analytics and IoT. And this is where we believe we, in the future, over the coming 3 to 5 years, really will find the next, let's call it golden nuggets for the companies and for the society that we are in and living in and working with. And I want to take you through how we see this area and a couple of success stories that we have been looking at and been doing to show you this is something that is actually live today. And if you want, please feel free to raise questions as we go along, or we can have them at the end. Going to slide 7. We see when we need to deliver IoT as a service, the service levels differ from what we normally would see in IT. We need to look at accurate business alerts. We need to look at speed of data. We need to look at quality and usability of the data, especially here about how the end users are getting access to the value that are driven out of the data. So what is the insight and how do we give the end users access to that insight? Timely alert for predictive maintenance of devices. So this is also a KPI that we're going to build in, because this is really important to show that we are enabling and improving a business process. So normally when we looked at IT, we looked at the number of incidences and uptime, etc. And it was very nice for a server or an SAP platform. But moving into the actual core business of our client, we need to have KPIs which are much more closer to the day-to-day life that they're working in. Give you an example, if you go into a production line and tell them that you give them 99.9 availability, they're going to laugh because they are working with 100%. They will say, you know, we need to run at all times. So 99.9 is not going to cut it for us. And that is a different thinking we need to apply here when we move into the area of IoT and adding analytics to it to ensure and to show that we actually can deliver the value at the other end. If you move to slide number 8. When we improve visibility, and we do that by using those new service level here, as you will see on slide 8, we also will give our clients more control, more real-time insights on timing, planning, condition, and quality. So we will help to increase the production time by reducing disruptive last-minute changes. We are going to ensure that we have better control and better planning to be more efficient around our warehousing. Coming back to decarbonization, we definitely want to reduce the carbon footprint by adding our solutions here to our clients and reducing, for example, energy consumption. I will come back to one specific example here a little bit later that will show you exactly how we do that. Now, telling you about what we want and how we want it, and also the benefits on a high level that our clients will get. So how are we now actually going to deliver this? What is the core idea and vision around us bringing that value to the client? And what do we believe the clients need to focus on to actually gain that delivery? So first of all, IoT, AI, analytics has been, over the last couple of years, really been exemplified by a lot of pilots and POCs that has shown that there's a value there, that there's a business case, but a lot of companies has not been able to materialize that business case. So why is the reason? One of the reasons is they have not been able to scale. The whole business case around IoT, analytics, and AI will come through scale. They will not come through a pilot, it will not come through a POC. It needs to scale across the shop floor of our clients or across the cities in the public sector when we do smart city solutions. That is where the business case comes for the clients, but also for society. For enabling that, we need to put together a full end-to-end service chain that can enable that scalability and that scale. This includes everything from the consulting part over the analytics and the app development, which is basically the visualization of the result, and then adding the managed service to it. We also need to ensure that this can be integrated and the connectivity is there. This includes also what we see as the some of the latest development coming there, where edge and managed edge computing are really rising and now becoming a more and more vital part of a full IoT solution. We need to ensure that we can optimize this service chain at all times. And of course, coming back on some of the points just raised before my presentation here, that this is secure. That this is a secure solution across the shop floor of the client, because we're really in the heart of their production. So this is a really vital point that we need to ensure. But we also need to ensure that we are working in an open ecosystem, because we're not able to realize the benefits of the client if we're not working together. And here, working together with startups, with scale-ups, with niche companies who has material knowledge on specific points that we then can add into the IoT solution. But also working together with some of our other partners, like Siemens, AWS, who brings a lot of scalability to it, or Siemens, who brings a lot of domain knowledge into our solution when we work together. So let's take it one step deeper and try to figure out how we see this moving and how we approach this from an ATOS perspective. A couple of years back, we started a program called Pre-Integrated IoT. The idea of that program was to ensure that we look at it from an holistic point of view. So that we look at it from an end customer point of view, so the users that are actually going to use this in a daily life. If they don't adopt it and that they are not using it, you can build the best solution of the world, it will not help you. We need to enable the open ecosystems, as I just talked about. We need to be able to connect and drive data from a lot of other IoT platforms, because we see that a lot of clients and customers have different IoT platforms based on the size of the actual production side, or of the size of the daughter companies, etc. And of course, we have the current IT systems and the legacy systems, which of course have a lot of data, and we need to capture those as well. And up top, we need to add the analytics and the intelligence. So what we did together with clients, and this is some of the clients that I'm going to tell you about a little bit later, we sit down and said, we want to develop an approach that's both scalable, but also vertical. And we want to do and move forward by doing co-creation and co-development with our clients. We do not anymore believe in that we can sit in a lab and find the best solution in the world, and then the world will embrace it when we bring it to them. No, we need to do it jointly. So we need to do it jointly in an ecosystem consisting of partners, but also about the client and the end users. So when we develop now a use case in IoT, we work with the client on site, in their production site, with our partners, and try to develop the solution. So how do we do it? If you look at slide 10, where we are at now, if you move forward to slide 10, and one more, please. One more ahead, please. Thank you. You will see that we have a structure from the shared function layer and downwards to the core infrastructure layer, which you can combine with a green Lego plate. So this is where you plug everything onto. We have established that with an IoT engine, and here we use typically some of the larger players in the markets like Siemens MindSphere or AWS as our core IoT engine. We then wrap it with some bidirectional communication platforms that we have developed, and we also add some microservices to it as kind of the glue that puts everything together, and surrounded, of course, with a strong cybersecurity. Now, on top of that green Lego plate, we can now add our use cases. And every company, regardless of size or competitor to Atos, can now add their use case to this green Lego plate. They add the use case, and the use case seamlessly moves through this stack here and connects to the IoT engine and a bidirectional communication platform, and can go out and get data from the devices, from other IoT platforms, from other IT systems, and even from external systems. So this is giving you the possibility to scale, because you can build, regardless of the size of your company, you can build a very specific use case, you add it here, and you immediately get access to the data that you need. And once you're through the pilot, you can go live, meaning you can simply roll out the app, because we are already connected, and we thereby scale across the shop floor of the client. Now, we can build this as a project, but the client can also get it actually as a managed service. So that means that we now can work with the full ecosystem, who can add their specific use cases to this pre-integrated reference architecture, which then will enable every use case to scale and every use case to be delivered as a service and or project, depending on what is the client needs. So this brings us to the right-hand side of the slide, where we now envision moving forward that we will, with that reference architecture, be able to create one centerpiece for the client, where the client can focus. This centerpiece will seamlessly connect out to any kind of surrounding systems, devices, data sources that the client will have. And thereby we, the client, the ecosystem of the client, have one piece to focus on. One piece where he needs to add his use cases. Now, this is now coming to actually starting the journey about driving value, because the first thing that will happen is that the time to market from idea to actually full rollout will be reduced with 45%. And we know that from current projects, for example, in Finland, where the client was having 9 months from idea to ready to roll out of 9 months. That was his time to market. Now we have reduced that to 4 months. That means that they will be able to get the return of investment faster, and they will have the benefit faster into the different production plants. So this is actually live. This is actually what we're doing today. And let's look into some more of those live use cases. If you move ahead. One slide ahead, please. So the classic one here is the predictive maintenance and machinery inspection. And we have now been able to move that to a level where we can automate it fully by adding it into this pre-integrated IoT architecture and adding AI, so full-scale AI, into this solution. So we will drive predictive maintenance of windmill, gears, and power generators. This is already happening today. We will document the process by using the AI and the robotics. And we will be able to do demand planning, forecasting, and supplier claims assessment. All of that in one solution following this reference architecture that I just showed you. So this is bringing the classical, let's say, IoT use case to a different and a new level. Let's move forward. Let's move one slide ahead. So is there also other solutions in this one? Yes, we're starting to go out and create more and more use cases. Currently, Atos has more than 120 use cases ready off the shelf, which are following this reference architecture and combining the value of IoT and AI. We are doing this across a lot of fields, and today not only looking at predictive maintenance, which was a classic one. We're looking at the city of Vienna, giving a possibility here to provide a control system. Our most famous case is probably Coca-Cola, where we are driving and connecting a use case of getting 17 million coolers online across the world, so that they know where they are, they know the condition of the cooler, they know what's in it, but they know also can start to use this data to see if the sales is actually good. You know, how many times are the door of the cooler actually open and close? Is the cooler placed in the right way? And they can now start to also combine that with the different marketing and sales campaigns. So hereby we're taking very classic low value data, collecting it, adding more value to it, adding AI analytics to those data, and are able to create much larger value at the client side, driving totally new business cases. Let's go to the next slide and come back to a couple of solutions that I mentioned in the beginning, which are really our flagship solutions for driving decarbonization, but also to using this pre-integrated reference architecture to the full extent. The first one I want to point out is about saving enormous fuel amounts for shipping industry. We're here working with a leading company within container transportation, and we have developed a solution which makes the ship fully connected as one kind of really big edge solution, collecting data from engine, from weather, from a lot of other things that are impacting the fuel consumption. And we are actually adding real AI to it at the edge with high performance computers on the vessel. Now, every time the vessel gets close to shore, it starts to offload the data into a cloud. The analytics models in the cloud will be updated, also with data from all other vessels, and they have more than 200 vessels. So the models will be better and trained, and the new models are pushed to the vessel again, so it can operate fully offline from the cloud with the learnings from other vessels. Now, fuel consumption here for this kind of industry is 50% of the cost. And we're talking fuel bills in the area of 3 to 4 billion euros a year for such companies. And we are on the edge here of driving that fuel consumption down with around 7 to 10% per year. So this is on the one side a lot of money, but on the other side, driving fuel consumption down as well as oil usage in general, also driving decarbonization down, or up actually. So by reducing the usage of fuel with 7 to 10%, we will have a huge impact on the decarbonization and the race of the decarbonization of that company. And now we can multiply that across the whole shipping industry, both for container vessels, but also the cruise liners and navies. So here we will be able to actually create an impact on the overall decarbonization goals from the Paris resolution. We're also working with one of the largest producer of vaccine. And here we created a full real-life digital twin of a chemical process, one of the core chemical process when you produce vaccines. So today, for the solution here, they needed to wait 4 to 6 weeks to see if the chemical reaction actually happened in the way that it should. Now we have been able to create a full real-life digital twin working alongside the actual process. So we can immediately see if the process runs as it should, and if the chemical mix as it should. And if not, we can start to reduce or impact temperature or pressure or speed of the fluids or whatever, impacts the chemical process. By that, we will reduce time to market immense. That means also less energy. So we can increase the production, but still using the same facility, the same time. So thereby, as I said, really reducing energy, but we're also reducing the usage of really expensive components. So thereby, we will hopefully also drive the cost down of the vaccine. So more vaccines and cheaper and faster to market. And also now we're looking into to use this solution for driving the R&D. So you can imagine you have a idea of what could be the vaccine for COVID. You knew how that would look in theory, and now you can start to see by using this digital twin here, if you actually can replicate it and build it by looking at the chemical process from different points of view very fast, and you will then in theory have a digital vaccines, and then you can start to see if you now can replicate it into real life. We are also increasing the paper mill operational efficiency. So those paper mills, those production lines are 300 to 400 meters long and almost 3 stories high. So here is also a lot of energy consumption that are used by that production. So the more efficient we can be here, less water, less energy will need to be used. And by able to increasing the overall equipment efficiency with more than 1% per production line, you will look at a company which have more than 90 production line, you will immediately see that this will be a huge impact, of course, to the business, but also to the energy and water consumption. Again, taking care of the environmental impact and increasing decarbonization. Let's move forward. Next slide, please. So this is the case of the global process industry. This is the challenges that we see, and where we work with this one paper company that I told you about how to increase the efficiency of this industry. We're talking really about big machinery here, as I said, but also a production which is extremely fast. The paper runs with more than 150 kilometers an hour, so you don't have much time to react. So how do we solve that challenge? Let's take a deep dive on it. Next slide, please. One slide forward, please. So what we did here specifically, coming back to the paper mill that I just talked about, was that we were actually able to create a smart control room. So we started to do event prediction. What does it mean? We actually looked at the alarms happening. So currently they have more than 200 or 300 alarms per hour, much more than a human person actually can react on. And when the alarm appear, they already were too late, because then the issue actually was happening. So we looked for pattern. We started to predict the alarms. We also started to tell them what is the root cause, so which alarm will actually be responsible for setting off other alarms. By that solution here, we were able to predict an alarm happening half an hour before it actually happened, with a likelihood of how it would happen, 70%, 80% if it would happen, yes or no. What are the other alarms that would be triggered? And what were the resolution that they could apply to it? For example, they have a big boiler, and if the boiler boils over when boiling wood pieces, they need to close the factory for a full day. So you can imagine both the business impact, but also the environmental impact. Normally, when they get the alarm of such a wood boiler boiling over, it's too late. They can go down, they can shut it off, and they need to find some shovel and start to clean the mess up. Now here we were able to give the prediction 20 minutes before it happened, meaning that they could go down very easily and turn the heat down and preventing the wood boiler from actually boiling over and be responsible for a full day shutdown of the production, which has a huge impact both to the daily life of the people here, coming back to the point of the end users, but also to the company and of course to the environment. So this really means that we need to ensure that the end users are using it, as I said, and they do it here because we develop it together with them. They were part of the development process. They took responsibility in using it, and today also we capture the changes that they would like. You tell us if you put it red or right or wrong, or how we should solve this or that issue, and the algorithm now captures that. So it captures the human interface, the human reaction to our predictions, and learns and get better from that. Really again showing how IoT, analytics, AI are working really hand in hand to create really tangible business value. Let's move ahead. Next slide, please. Here you can deep dive a little bit more into we did it. I think I have explained very nicely about it. The solutions here was created with one of our partners, Siemens, and actually using the methodology and the reference architecture that I talked about called pre-integrated IoT. Let's move to the next one. Next slide, please. So this is the digital twin that I talked about for the physically process for vaccines, for example. But of course, digital twin can also be used for other solutions. You can have a digital twin for a windmill. You can make one for your car production. So today, there's a lot of option in using digital twins enhanced with IoT and AI analytics, really to drive and improve your business process, both to the benefit of the company, but also to the benefit of the environment. The better the windmill operates, the more energy it will create. There's a benefit from for the company, but it's also a benefit for the environment because we will have more wind energy, meaning we will have less energy coming from normal, traditional carbon footprint heavy as fuel solutions. Let's move forward. Let's move on slide forward. So as I said, we built this for the vaccine production, and this is real life now today. And we can now either tell the operator to change, shift, or add pressure, temperature to it, or we could actually automate it fully if we were allowed to. So this, as I said, really are impacting the vaccine production And we hope, of course, that this also will help us to overcome the current situation that we're in. Let's move on, slide ahead. This is the first generation of the process digital twin that I told you about, with a guaranteed product quality. As I said, we really reduce raw material here and the waste from it, and you can see this is really a heavy reduction. And a faster time to market, we believe we can bring up to a 50%. Just to give you some of the actual metrics around this. So we're not talking about, we will save them 1 hour here and there. This is massive impact. Let's move forward. So will this only be something that we do within the industry and within companies? No. We clearly see this also happening within society and within the public space. Decarbonization of cities. Clearly here we can work with the cities with kind of smart city solutions. Just one really tiny example. So for example, we have a solution when fire trucks or police or ambulances need to get to a certain point in a city. Normally they would drive around and try to get there. We have now given them a solution which are doing real-time analysis on the actual traffic, compare it to traffic at similar situation, at similar days in the city, but at the same time we're adding information about the length of the street or the width of the street, to see if a police car or an ambulance or a truck, a fire truck actually can, get into the street, and if they actually can turn in the street, or if it's typically a car park there, or the streets are too narrow. So this is on the one side improving speed for the blue light, police, fire truck, ambulances, but also reducing actually their carbon footprint. We will see models arising within democracy, and hopefully increasing the digital engagement with their governments. So this is something that really are picking up, and we will see those solutions appear more and more really in the near future. Let's move forward. While we're moving one slide ahead here, one example is, of course, the COVID-19 issue, which also now are giving us the ability for governments to track chains of the disease and how the disease will tend to over from one person to another person. So it gives them a lot of management possibilities of engaging with, for example, pandemics. Now, if you would like to engage with ATOS, and I hope you would like that as students and listeners here, we have a lot of possibilities. If you go one slide ahead, please. One slide ahead, please. So you will find us as ATOS.net, and there's a lot of possibilities that you can work with us around. One is around our collaboration for startups called Scale Up. One is our digital or IT challenge for students that we have every year. The other one is, of course, to apply for an internship or to work with my teams globally on your master thesis. Other things that could, work for you. And if you're a partner, happily would like to set up a meeting with you, talk with you about how we can work together and how we can drive value for our clients and for the benefits of the society moving forward. With that, I would like to thank you, and hopefully there's a lot of questions.
Yeah, wonderful. Thank you very much for this great presentation. So you only have 5 more minutes, right?
Oh, we can take it to 10 minutes if needed. No worries.
Because if we take 10 minutes, then I would put the people for like 3 minutes into the breakout so that they can discuss a bit about the talk and the questions. Yeah. You will also be put in one if you want to discuss with them, feel free to do so. And then I would say let's do a shorter one now. So be back in 3 minutes. I'll just do the breakouts. Just have to end this stream here. Okay. So, breakout rooms. We still have at least 2 people open our rooms. Okay.
So, Mr. Thompson, I apologize for the delay with the next slide thing. That was like a rebroadcast of the YouTube stream, which has a delay of about 5 seconds. So I did move forward, but it only got to you a few seconds later. So I apologize.
No worries. It worked, we made it through, so all good. All good.
Yeah, exactly. So, but besides that, I can tell you the YouTube stream was perfect. So it went super smooth. You will see it's really nice. Okay,
great.
So the people are back in 10 seconds.
No worries. I hope you solved your sound issues.
Yeah, it was horrible. Actually, the Zoom was breaking the audio in this computer, and then yeah, it was horrible. But I'm very happy that it's working now. And sorry once again, because it was, for me, it was the worst, because I was sitting here like, oh no, we have everything, but we were not allowed to test yesterday. Okay, so the people are back. I would take the chance to ask the first question, just free out here. I actually have 2 questions. So the first one would be the heterogeneity. How do you make the people adapt to your platform? How do you make them, or what can be done to overcome this heterogeneity? Because your platform is connecting the different ecosystems the way I understood it, and which is great because then you have interoperability. You can bring all these fantastic use cases. Is it difficult to convince the people? Are they more like, yeah, cool, we want to come because this is exactly what we waited for? This will be my question.
No, it depends a little bit where you are in the organization. If you go to the let's say the more upper part of an organization, you know, they find it quite cool and they see the benefits, etc. And if you then start on the people that need to execute it and live with it on a day-to-day, and that's the important part, because if they are not on board, you can build the finest solution and the most wonderful solution of the world, but if no one is using it, the benefits are not there. So they, of course, you know, and you need to put yourself in their shoes. They, of course, sometimes are afraid, and they have also sometimes been exposed to a lot of POCs and pilots, and they're, you know, just another one, yeah, that's nice, and this will also bring nothing, etc. So this is not easy, and the way that we did it, and that we're doing it right now is very old-fashioned. It's really to go out there and physically go out there. This is hard now under the COVID times, yes. But normally we went out, you know, to take this paper production plant again. We went out 300 kilometers into the woods of Sweden and sat down with them 2 times a day, every 2 weeks. And we really sat down with the operators, first to learn about their day-to-day life, then to talk with them, then to understand what the issues are. Then, you know, a lot of talk meetings to understand and really listen to them. And then we started to develop, but with them. We really engaged them, gave them different tasks, gave them feedback possibilities, etc., so that they felt engaged on the whole process, and thereby they took ownership and also found it quite cool at the end, because then they had something that they had on their cell phone, and they could maybe go home earlier and still be at work. Suddenly getting, it's not a lot of home office if you're looking at a 400-meter long, 3 stories high paper production line. But with putting a lot of the stuff to your cell phone or tablets or whatever, they suddenly had some more flexibility and other things they could do. So it's really around engaging them, working with them. I cannot, underline the word with enough.
And this is also probably something fascinating when you do such collaborative work, that you then see the clients and you really see that they're happy. And it's not you have a product off the shelf and then they do something with it, but you don't have contact. But it's more this different doing something together to drive it even much higher.
Exactly.
Yeah, so do we have a question from the chat at the moment? Okay, because then it's very good, because then I can ask my second question. What would you say is the biggest challenge a student should focus on right now when you think about this change of the systems, integration of everything? What would you say? Is it, when you're studying right now, you should go for right now? Is it still AI? Is it the next big thing already?
AI, IoT are there, and of course we need to drive that further. We need to understand it better. We need to be better in using it, and we need to put it to the edge. We believe that a lot of AI models need to run exactly on the edge, like the vessel solution. So that's one part of it. Then we need to make sure that it's extreme secure. Just imagine if a terrorist hacker would get access to a vessel, or an oil tanker, or a container vessel with 20,000 containers on it. What kind of damages could it actually be done? So it needs to be very, very secure. And then, because technology is not the biggest issue nowadays, it's actually people. It's our imagination and our belief in what is actually doable. That needs to be changed. And as I said in the beginning, we need to be able to scale. So we have seen, and I'm talking about business now and also cities, we have seen that a lot of pilots and POCs has been done, but things have stopped there because we're not standardizing, we're not scaling. So the benefits will not come without a scale effect. So that is really one of the big challenges as well. And then, of course, it needs to be more than about business. Of course, there needs to be a business outcome. We need to focus on that. We do not need to focus on technology. Stop that. Focus on the business outcome, but also focus on the impact that we can bring to the environment. It's crucial, and we need to take it serious, and we need to use those technologies to create both sides of the equation.
And when you think about the change process that you said that there's more collaboration, does this also change the value chain? Are you closer to the customer? Can you say something?
We are working in extremely close collaboration nowadays. And let me again give you the example of the paper mill, but also on the vessels. And we were out on the vessels. We were sailing with them. And for the paper mill, we worked here with partners, for example, with Siemens. We worked really the client, IT organization and change organization. They are actually production sites, us and Siemens. So basically 4 teams spread across the world. We needed to have high engagement. We needed to be on site at some point. And we make it happen that the teams work so close together that I went into the final steer code. I was not able to find out which person came from which company. They really went to be one big team. That's where we need to go.
Oh, that's
we need to take down the barriers. We need to believe in the open ecosystem. There's value enough for all of us there. And that's how we bring it.
Very good. So we have 2 more questions. So I hand over to Nicola, who probably still has his microphone.
Can you hear me?
Yes.
Yes. So this is one question from the chat that I can read here. So you were mentioning the process of co-creation and co-development of customers to find their specific needs. And I believe an essential aspect of such collaborative work is a trust between you and your client. How do you establish such trust with your customers and so they are open to you?
Oh, that's a very good question. I would have loved to say that we do it over a very nice digital solution and we show a lot of benefits and so forth. That's a part of the answer, of course. But the more important answer is interaction. Really talk with people. Sit down, talk with them. Go out, have a beer or a cup of coffee or whatever, you know, makes it happen. You need to talk and embrace the situation that the client is in. And you need to get that trust. And the only way you can get trust between people is to communicate and talk with each other. And it's sadly to say, it's that old-fashioned. There's no silver bullet. It's hard work. And the other part is, once you have gained that trust, you need to show them that you're taking that serious, what they tell you. So it's not about, you know, we sit down, listen, we have a cup of coffee and it's very nice, and then go back and do something totally different. No, you need actually to take that with you and come back and show that you have understood what the person was saying, and that you actually are listening and you're creating a solution that will help that specific person in his role. So this is how we create trust. I don't know if that answers your question, but it's really about people meeting people. And as one person told me when I started my career, he told me a business, a project is not done between two companies. It's done between two persons, two people. And that has been my mantra, and that's what I'm bringing to my teams. And that is what I believe by the end of the day will create the trust, together with the commitment to show that we actually are capable and able of then turning it into real solutions.
Thank you very much. I have another question. So what are the skills students need to develop to be able to work in such projects?
Sorry, could you repeat? I couldn't hear the question.
Yes. A student is asking, what are the skills students need to develop to be able to work in such projects?
Oh, well, that's also another good question. First of all, you need to be open by nature. You need to be, you know, keen on talking with people. But I don't know if that's a skill or a personality. But you definitely need to be open to that. Of course, you need to understand how your domain works. If you're an AI person or an IoT person or whatever. So you need to have your specialty under control, but you also need to understand, let's say, the surroundings that are around it. So how does my specialty interact with the other areas? And that knowledge is also needed moving forward. So you cannot go into the silos and just say, I'm only doing this. The world of old IT silos, that will disappear. So you need to have your specialty, you need to be open to talk with people, and you need to understand how your specialty interact with the surrounding world around you. So what is the solutions or the specialties and capabilities that have borderlines to you, where you have a border that you can work with, and you need to understand, not to be a specialist in that area as well, but you need to have an understanding how that works so you can create that dialogue. And then you need to be understanding that this is not about technology anymore. You know, it's great about technology. I like technology myself, don't get me wrong, but when we're out there talking with people about those projects, we need to understand that we're there to solve the issue for them. And they don't care if we use AWS or if we use Siemens or if we use this or that coding language. They care about the issue getting solved. So that is, I would say, one important skill to bring with you.
Good, thank you. And I have one last question from the chat about digital twin. So digital twin needs to be connected to the physical process. And the question is how difficult is to create this connection between the physical world and the digital one. And
I'd say it's doable, and I will not say it's you know, something that is rocket science nowadays. But the feedback loop, as we call it, is really the important part, but it's also the most complex part. So it's something that is doable. It's not off the shelf yet. It's also not something, you know, where we do not believe it's doable. We know how to do it and we can replicate it, but still one of the more complex parts of the whole setup and the whole solution. We need to create that feedback loop between the real world and the digital world.
Okay,
Thank
very
you very
good.
much.
Then maybe we use the opportunity of having multiple people here to give a warm applause to you.
Thank you. And thank you for inviting me.
Representative for the more than 50 people in the stream. So thank you very much. And yeah, thanks.
Thank you. Have a very nice day and enjoy. Bye-bye.
Perfect. Thank you very much. And so those people that stay with us as announced, so we'll have now a 20 minutes break. So we'll continue at 3:30. Yeah, exactly. So you can stay connected, of course, and we'll continue with the program at 3:30. So see you in a few minutes. peux commencer? Okay, not sure if you could see the trailer. I hope so. Besides that, let me just switch the screen so that I can also see me. However I do that. Okay, perfect. Good. So yeah, it's my greatest pleasure and honor to welcome Emmanuel Bricard, who is the Chief Information Officer at Irland Leblanc, expert both in IT engineering and in project and business management. He is specialized in IT strategy, mobile devices, Industry 4.0, and lean management. He has been working for Irland Leblanc for more than 10 years, driving the digital transformation into the company. So I directly hand over to you, Emmanuel, and we're looking forward to your keynote.
Thank you, Mark Oliver. Hi, everyone. I'm very glad to be here, and thanks for the great opportunity to present this keynote about enhance company resilience through cybersecurity. So just a little bit about myself. So I'm working for ILM Leblanc, which is a subsidiary of Bosch. We are making boilers, heating system, and clean systems, and basically Bosch under all its brands umbrella is the leader in the Western Europe of heating systems. So in this company, I'm here since since Saturday. It's been 15 years that I joined ILM Leblanc and Bosch. It's been a great ride, and we did a lot of very intense and very passionate projects on a lot of technologies. It's funny because when I remember my first interview there, I would have not thought about how many IT high-end topic would be important for such a traditional industry like heating. So to finish the portrait of ILM Leblanc, we have about 1,000 collaborators in France. We have 2 production plants, and as we are part of the Bosch Thermotechnology division, we have a lot of exchanges with other plants, sharing best practices and technologies. So basically, I'm a science fiction fan. I was raised without TV, and then I read a lot of books, tons of books, thousands of books, especially science fiction one. My dad was really fanatic of it and transferred that to me. And what I like with science fiction is how it explores the world, of course, with anticipation visions, but how technologies will shape the world in the future. This is really what science fiction is. It's not like Star Wars battles with lasers or whatever. It's really about how technology shaped the world. And when you read science fiction books, most of them have been written by some technology experts. Most of them are researchers. And somehow it probably gave me my first steps in direction to IT, preparing me to try to be part of that change that new technology brings over the world. I'm a former developer, so I started developing C# solution as well as PHP and a lot of other things, designing database and doing a lot of stuff for services activity, mobile devices, as well as industry solutions that I worked on, in the 2010s, and that are still operational today. What I like with IT is that I really believe that it's a power we can use to improve the other people's life. Most people do not know what is feasible with IT, and usually they are shy to ask something. And when we fight a little bit to develop a great solution, usually hundreds of, maybe thousands of people can benefit from it every day. So it's worth it, and I believe for me, it's a chance to be able to have such a positive impact on a lot of people, a lot of colleagues' life. So I really enjoy that. So I have this background, and I'm really overall passionate about how new technology shape the world. And basically, what I was reading when I was a child is now becoming more and more reality. When you talk about AI, when you talk about augmented reality, things like that are coming to life. And I even have some projects working on using those technologies. So yeah, I'm really pleased to be at such a place where I understand the world how it is today, and I can act to make it, I hope, better tomorrow. So I'm not, so maybe this is a big difference between me and all the other speakers. I'm not at all a security expert, which means from my professional point of view, I'm a user of security. I work with security firms, security expert at Bosch, when I need to design a new solution or when we do some security reviews of existing systems. Security is everywhere because IT systems are everywhere and connected systems are spreading even more everywhere. But I give you the point of view of the non-expert guy, and regarding security, and well, maybe this will give a specific point of view, but it may be also bringing some hints of what you and I'm talking to the PhD students there and all the students that are working on security, what you can provide to people like us that are from the industry or from IT or both, but that are not at all security experts. And how the world is changing and how you can help us to face those changes. So you all know of course, digital transformation. I'll be quick on that. It's not a wave like previous revolutions. First revolution was based on steam engine, and then the electricity made the second one. Then the third one was on IT and chips and all the electronic components. But for this new wave, whatever how we call it, it's a lot of technology that comes wave by wave in parallel, and the more time flies and the more you got a larger number of waves that spread all around the world, and that change everything. Of course, it somehow started with the internet. Of course, 1990s were not the years of the internet, but it's the beginning of internet spreading to every homes at the end of the 1990s, and of course in universities, in all universities, and bringing online some lot of new potential, some opportunities, some websites, and so on. So the iPhone is 2007, so it's just a little bit more 10 years old. And when you look at how it shaped the world today, it's just crazy to see such impact, and how we are closely related to our smartphones today, and how it impacts the world, how we always look at these screens all the time. And so it's enormous, and it's only 13 years old. IoT at home, the same thing like internet. Of course, it started before, but since the years 2000s, it started to spread in every homes, and now you got 30% of houses in the US that have some Alexa or Google Home devices, and it's growing faster and faster. Because the more some people have it, and the more they convince the others to try it and use it, and this is all accelerating. And of course, the smartphone was one device doing so many things, killing so many other devices in the past, like the camera, video games, the MP3 player, and so on. IoT at home will change as well so many aspects, so many things that we have in our homes, as well as create new businesses, new opportunities. Everything can be connected at home. So of course we start with the lights and the AI assistants, but it's just a very small beginning. And in the industry, you got the same thing with what we call Industry 4.0. So IoT devices are spreading more and more everywhere. Everyone knows that in the short-term future, all machines will be connected, all people will be connected. They all use some new kind of devices and tools that will work autonomously or semi-autonomously together to have some plans that are more flexible, that are able to do more personalization of products for customers, and so on and so on. And this is just few examples, but the waves are still continuing to expand and bring a lot of new technologies. And this is just the new normal, that this change will continue all the time and we continue to grow. And we never had a period of time in our human history while in such a small scale of time everything was changing fast. And even if in the 1930, Walt Disney, you know, the creator of Mickey Mouse, was saying that the world is going so fast today. It's almost a century later, it's still the same thing, but of course it's way more accelerated, and it looks like it's accelerating exponentially as a stable basis for tomorrow's world. So the world is changing in a deeper way every day, which means it's very easy to be left aside. And it's, let's say, it's our role from IT people, from technical people, from open mind with a close connection to technology, to help the others to engage with this new world that is changing all the time. And of course, when you have all these technologies coming, of course, they are all based about IoT device, IP devices, or even LoRa or Sigfox, new kind of devices. But all those things are connected, and all those things can be hacked. So while the technology front enlarge all the time exponentially, then the threat front enlarge as well. So yeah, one thing, John Carter is a very famous, probably the most famous management consultant. He wrote a lot of books that have been bought, that have made records in the New York Times and so on. And what he's saying is that now this change is permanent, and what is constant is that everything will continue to change. And what it does not say there, but what he says in a lot of interviews is that it will continue to accelerate all the time, and it is just the beginning. It's the new normal. So what is digital transformation? First, it's cultural change, because we need to be aware of this change, embrace it, to accept that our daily life unlike what happened to our parents and their parents, is changing all the time, which means we won't have only one job. We have to learn all the time. I personally believe it's a great thing to learn all the time because this is where you stay in good shape. But some people were not trained to that, and it's important that we spread the word that it's a matter of, it's vital to be able to learn all your life and evolve this way and help the others to do the same. In this change, the first aspect is the consumer-centric part. And yeah, you got a great example tomorrow morning with Amazon keynote about that, how to bring a new consumer-centric approach, and of course data mindset, because it's been about 10 years that everyone's saying data is the new gold mine, data is the new oil and whatever. But it's great to save it. Now change the process in the company to be able to manage all those data during all their lives, from the creation of a project to the end, to the replacement of a device, is something that is far from being into the culture of most companies. And this is critical if you want to be able to do some AI tomorrow, because of course data is the gas you need for AI. So develop this new consumer-centric and the data mindset are the first things of this digital transformation. Then the second one, disruption. Disruptions happens in all kind of industries, and those who are not disrupted yet are afraid of the next disruption. And of course, they are aware that they need to change because something will change. If they do not bring these disruptions, it will be a startup or competitors. So how to be able to bring those new culture of changing what works when it still works, to try something else before someone else does this better than you. And then of course, connect to the world through the cloud and IoT. So just the cloud, it's something that has been very complicated to a lot of companies, especially for IT people, because usually we IT people had legacy systems that we tried to protect as much as we could, and suddenly we need to go into some third-party suppliers that has to manage our security for us, Amazon Web Services and Azure and so on. So it's a profound responsibility change, and it's been hard to accept in a lot of groups and companies, because a lot of companies believe their IT were assets, and it's been a hard change that slows down probably a lot of groups to make the transition. And of course, IoT, when you have IoTs, you cannot control everything from your own legacy systems. IoT connects to the cloud, of course, and especially when you talk about edge computing. So these IoT devices are not working only for you, they're working for your customers, they're working at some point on the value chain level, and you need to be able to connect with all this. We're thinking completely differently the concept of security. So the last aspect that is really important is, because of all those waves of technology, you cannot do everything yourself. Whatever how big you are, whatever if your group is billions of dollars and have a lot of cash, you cannot be expert of everything. You cannot be expert of all those technological waves that are coming faster and faster, which means more and more you need to be able to develop new ways of working with, like, academics, for example. We have a strong partnership with IMT, Institut Mines Telecom, and it allowed us to do a lot of new research and development that we were not able to do before. New ways of working also more and more involved using open source solutions, while in some groups it's still forbidden, but it's again, in the sense of history, if you do not reinvent the wheel, you can go way faster and way further. So so such changes are, before everything else, before any technical discussions, It's more than everything cultural changes. So questions of all the big companies are, okay, I want to disrupt my market, but I'm a big group, I'm not a startup. So how can I be fast and agile like a startup while being secure and being able to industrialize things with security and the reliable system that that our customers are expecting from us? And there's a big kind of schizophrenia, maybe, comparing both models and trying to adapt them because they are so different. An agile organization focused on customer experience, like a startup, will really go into the key value of its offer to the customer, while a big company usually is based on one thing called risk management. And that is covered usually by a lot of standards that are defined at the top and that goes down. And sometimes in more evolved groups, it's defined collaboratively on the field, but it's not always the case. And this risk management approach is hardly able to cohabitate with agile organization. So this is a big problem because most organizations have a hard time to, while they know they have to change, while they see all startup working and bringing faster than they could ever dream some new technologies and new offers, well, they just stay working the same way with their risk management approach, and everyone is protecting himself, and every procedure is supposed to make people to do good things, whatever happens. And instead of pushing leadership and autonomy and responsibility, such approach is just killing big groups, and most of them will disappear because of that simple reason. So John Carter proposed a great video about this. You can look at in YouTube, moving in a faster and faster moving world, and he has an answer to that. And the crazy thing is that company and groups are knowing that and still have a hard time to embrace a different model, even if they know they are too slow. And all this is amplified in this world of hyperconnectivity, because with IoT and edge solution, what we had from an IT security in legacy system was to use the castle approach, where you had this big castle that were protected and nobody was able to entrance, no intruder was allowed because it was detected on the periphery. And now with IoT, of course, you have your castle, but then you have potentially billions of devices all around, or millions of devices, whatever, that connects to your castle. And then this means the castle itself has so many entrants that is very hard to protect it. And so there's a lot of security models, and a lot of you are knowing them way better than I will ever, like zero trust approach and things like that. And so this is a big problem, how to cope with IoT solutions if you don't want to go into the edge and into the cloud. And then if you want to go into the cloud, probably that you need to get rid of your legacy system as much as possible, because keeping both approach, cloud solution and legacy castle approach solutions, are creating, because they are combined, a huge complexity that makes it very hard to maintain, and add a lot of work to and a lot of uncertainty to the IT teams that needs to manage the old good world and the new one that they need to learn to be efficient at that, and so on. And at the same time, you also have a lot of other IoT devices that are bring by your colleagues, by yourself, like you bring your phone because you like to use such phone and not the company one, and you use a lot of devices basically in your daily life that that are some potential IoT devices that have embedded firmware, like headset or whatever. You have so many things that have intelligence inside, and that seems harmless, but they are not. I put this window because HP put a report where they were stating that someone in one of the customers were just using this smoking device, and it was plugged on the laptop just to be recharged. But he has malicious code inside, and then was able to send data from the company away in some foreign countries. So even if those examples are quite rare, they happen. And so the company now is tied between the IoT solutions they need to develop and the IoT device it brings to its collaborators. And at the same time, there's also a lot of other shadow IoT devices that are used by the collaborators, and most of them don't even know the risk, even if you do a lot of trainings, because they do not have this culture, and it adds an even harder to fight layer of complexity. And so clearly, there's a need to have a new approach and leave this castle approach that was probably needed at some point in time, but now that looks completely out of today's time. So this was what happened, and then all this was amplified even before COVID-19 in what we call the VUCA world, because things are changing faster and faster, and some geopolitical events have some big impacts on the business. I will give you some few examples. So in the Bosch division, we have a big plant in Turkey that is nine times bigger than the one we have in Drancy, for example, next to Paris. And then a military coup d'etat happened in Turkey in 2016. And before this, France was seen as a high-cost country, and Turkey was seen as a less expensive country. So let's put a lot of resources there, let's build all of boilers there because it's not expensive, they are good, so it's fine. And after this coup d'etat, what happened is that France is still a high-cost country, but it's stable. What the Yellow Jacket are doing, at least they put some smokes in the Champs-Élysées, and they do a lot of fireworks and things like that. But at least they do not stop our factories to create borders and so on. Even if it has been complicated time, it was not a coup d'etat. And Turkey was suddenly not that expensive, but potentially very unstable. Which means, from a business point of view, you need backups. You need to be able to produce those boilers tomorrow, maybe somewhere else, because if something happens, you cannot deliver your customer anymore. So this is one example. Of course, you see others, the Brexit in France, in our Brittany plant, we are creating tanks, stainless steel tanks for the British market. And with the Brexit, of course, the valuation of the monies changed. And when the pound dropped, our tanks that we produced in France were, of course, less relevant in the UK market, because when you create something in euro, when the pound is down, then it's harder to sell it in the UK market. And so, of course, we reduced the production capacity for the UK market because it makes no sense. It was not making any more sense. And so you see how a few examples of how the events, the context impact the business directly, and concretely change the way we are able or not to answer some markets, and even the way some markets are dying. If I take the climate change, Macron government, so in French, a lot of people say Macron, nothing happens, he's doing nothing, and blah, blah, blah. In the heating market, we know that it's not exactly the truth, because they decided to kill oil boilers, which have been here since a while. And even if new oil boilers were creating less pollution than former ones, then the government said, okay, within the next 10 years, we'll kill these activities in France. And of course, they say that in December 2018. You can imagine how many orders of oil boilers we got in January 2019. So it was a direct, immediate impact, and how political decisions could influence the customer choices. and in that area, most of them just postpone their purchase because they do not know what to buy. Because in a lot of cases, it's hard to put something else than an oil boiler instead of an oil boiler. So sometimes you can put an heat pump and it's great, but sometimes not. So anyway, just some example of how the world is going more and more to be unpredictable. And again, like the changes you see in digital transformation, where the change is now permanent, it looks like even from geopolitical point of view, it's exactly the same. Companies will need to be able to adapt to some things that are unpredictable, that have nothing to do with themselves, but that impacts directly their business and that make them suffer and sometimes disappear. So it was already very, very, very complex. And then the COVID pandemic started. And then suddenly the digital transformation that was so complicated to explain to people from companies and the IT division who did not always wanted to go to the cloud and so on. A lot of corporate IT security experts were saying, you know, we should not go too fast. We are good with our great legacy security systems and so on. So do not move to the cloud, because I even heard sometimes that the cloud is only something that benefits to the cloud provider, which was a strange vision of things, but very interesting anyway. And then suddenly with the COVID pandemic, you saw probably in LinkedIn that this picture, who led the digital transformation of your company? Is it the CEO? This is the CTO, or is it the COVID-19? Of course, it's the COVID-19. Suddenly, you just could not work on the office. Then you had to find some ways, and some ways means some digital tools that a lot of teams refused to use before. I can give you some example, very concrete. We got, before the COVID-19 pandemic, a lot of orders coming from customers using fax systems, you know, the old machines that probably that most students here never saw in their lives. In my team, one new apprentice told me, I never saw a fax in my life before coming here. And what I was hearing when I was discussing with the sales manager, you know, our customers, they love to use fax. It's in their habit, so they do not like to change. They like it like that. And some fax were received. Then you need to have some people taking care of those. And even sometimes those faxes were scanned to be digitally stored and archived. So it makes no sense, but well, all the time I was hearing that, okay, but the customer wants it, you know, it's fine, they love to work this way, we cannot shock them and so on. We need to listen to the customer. Okay, I was very surprised, but anyway, suddenly with the pandemic, of course, all fax stopped because it was not possible to get fax anymore. And we implemented, of course, some fax to mail things, but suddenly everyone was going to a full digital mode, and including those customers that were supposedly very happy to use a fax. And so all companies saw a very strong acceleration regarding digital transformation. So some say we saw, like Microsoft, they say we saw 2 years of digital transformation in 2 months. Some say it's 3 years in 3 months, but whatever. A lot of companies move to the next level of digital transformation. And a lot of them discovered a lot of new potentials, and it's great. But of course, this happens in crisis mode, which means we did some crazy things that from a security point of view looked impossible a couple of years ago, like take a desktop computer from your company and put it at home because it needs to work, and you need to work, and you have no ways you have not enough laptops, so you need to bring some device to people. And a lot of crazy solutions happened, and this changed. And as it is transformation, this change in the root of how we work together, and there's a before and an after. And so the question is how we will do tomorrow, because of all those changes, the VUCA world, the pandemic, and of course, probably the biggest challenge of our life that we will face in the future. And then the younger one here will face even more than us, is the environmental change. So for companies, the most important thing now is how to survive. And this is called resilience, how to survive to shocks, how to cope with all these unpredictable changes from an individual level and from a corporate level. In all the layer of our civilization, basically, how to be resilient, to continue our activities, to expand, to embrace new opportunities, and all this in this digital accelerated world is more and more connected. So this is what we call digital resilience, how the companies can rely on digital to be able to survive all those changes that is the new normal. So of course, this quest for resilience is something that's happening at all kind of level, individual level, and we saw all the change that we had. All the people that suffer from the confinement, at least in France, we had this big confinement, multiple months, and it was hard for some people to stay home and have the ability to work or being unable to work sometimes. So it's a big change. Home office brings some new ways of working, and then for a lot of social groups, for a lot of people, it's been an opportunity as well as a threat. How to work together as a companies, of course. When you create a team, I created my team in 2010, and when you create a team, at least in the past, we had this sense of proximity. We share some space, some physical space together. We grow together. We listen to each other. We smile to each other. We learn to live next to each other, and this is how the team grows. And then you can have great team spirit, and you can develop your company and do a lot of projects and support each other's and grow together. This is the key. How to do all that in distance? Because of course, and I'm totally with Mark Oliver and all the organizer of this event. We prepare challenges to be able to do some concrete things together next to each other to challenge the students and so on, and have a lot of great things. Now it's different, and we'll have that later, I hope. But it's a clear example of how we need to reinvent ourselves to be able to, survive, change, and even enjoy that, because it may last. It's been a while already that the COVID started, and it may continue to last. And even when it will be stopped, maybe something else will come, and something else will come, but probably with different forms. So we are more and more relying on digital technologies for everything we do, for private life, for work activities, and this is just the beginning, which means the security part of things is going to be more and more important. So I'll skip that because I have not much time, but then for this resilience, you have a lot of challenge to face, and especially change your mindset to be able to accept all those changes and set new strategic challenge that may lead to new business models at the end. Be able to find the resources to change for the future, because when everything is fine, how to say, okay, I need additional resources, or I grab this resource that are working on this successful project to put them on something else that may bring no results, or that may create a marvel. We don't know, but we need to invent, we need to experiment, because if we don't do it, we may be disrupted tomorrow. And ideological challenge, because right now you have all those groups that buy each other's and so on, and they want to optimize everything and get more money and the bottom line in what matters. And at some point in time, when you are in a quest for resilience, maybe it's not the most important thing. Maybe the most important thing is the link you have with your employees, with your customer, and that you are able to last, and that you are able to evolve as the world evolves. And this is completely different. So it's a shift that you need to embrace. And so how to look at to evolve? Well, there's a lot of source of inspiration. Of course, in Asia, I took some sources that I know better. So of course, you can look at how the GAFM are working, how some new industrial companies are working, like Tesla or SpaceX. And basically, it's all about strong leadership, the opportunity to be able to do things, and we'll see that with Facebook, customer-centric culture and innovation, and an organization that is a little bit more open to the world than it was in the past. And of course, agile development and all that. The right method that comes from IT, but that you can reuse in different forms in all industries, basically, and all activities. So in SpaceX, what happened? Well, you have this leader, Elon Musk, that inspires these guys with a strong mission. With Tesla, accelerate the world transition to sustainable energy, and with SpaceX, making human a multi-planetary species. How you can be bigger than that? So his leadership is an example, and of course, a lot of people do not like him, but those who join probably love him, and this is how he's able to do a lot more than, let's say, Boeing, with a lot less money and experience. And of course, he has this culture of failure that is authorized, which is a new thing in a lot of other companies, like NASA, for example. At least it's what he says, that you need to fail, because if you're not failing, then you are not innovating enough. And you see it when SpaceX blow up its new test prototype for its new spacecraft. Well, they are learning, and some blows up, but then if they have the cash, they will be able to succeed. And they have the cash right now. Another example, after leadership, is the opportunity to be able to do things. And this is probably a big problem in a lot of groups, that Facebook answer with its own way. That can be scary, because yeah, clearly it's a very strong approach. It's a bold choice. They say that engineers at Facebook can create their own version of Facebook and test those versions on tens of thousands of users, which means if I was a Facebook developer, I would have an idea, I would share it with the others, develop my own version of some part of Facebook, and test it in real life. And of course, it can lead to mistakes, and we saw it on the data security part, of course. But the question Mark Zuckerberg asked is, will this destroy Facebook? If not, let them test. They pay $5 billion because of the data leak that we all know, but whatever, they have so many. So it's a kind of approach. I do not think it's really ethical, but it's a way to crush your competitors. In Amazon, you got this extreme culture of customer-centric innovation, and I won't go into the details, but I really love the methodology that they developed, working backwards from the customer. That will be presented tomorrow morning. So I'm eager to discover that with you tomorrow morning. And at Microsoft, it's crazy how this company changed, because if you remember, a couple of years ago, Linux was the enemy. It was a monster that has to disappear, and that Steve Ballmer wanted to kill. And now Satya Nadella is embracing open source world more than ever. They bought GitHub for $2 billion, and they are one of the biggest contributor to open source, with heavy investment since 2016. And of course, they do not do it because it's only a new mindset change, but because they can think about concrete results, about doing that strategy to develop themselves, get developers, support, and so on. So the question is, okay, how you can combine security and taking daily risk? Because you have this big group organization who know they need to change, and at the same time, they try to develop this risk culture, but they have all those procedures to be able to cover themselves, to avoid mistakes. And they have all these new companies that have some very extreme approach, but that allows them to grab new markets, grab millions of new customers, or billion in case of Facebook. And well, is it ethical or not? But at least some of them are having some incredible results by lowering the expectation on quality. And of course, when you look at security in the world of hyperconnectivity, where you have some IT device connected everywhere, how you can combine both? This is a key question, and I think nobody has the perfect answer to that. But it's very tricky. And I'll give you some example for the future that are very questionable. Of course, in the future of IoT, you'll have all those self-driving cars and infrastructure, the car connected to the other cars and to all the infrastructures of cities and the railways and so on, and highways. And something that I really love, the development of wearables and augmented reality, and before even connected medicine that will come later. And I have a project where I have 5 PhD students working with 3 labs in the IMT, which is called Ironman. This is a code name, of course. And we designing using HoloLens 2, a software-based solution of mixed reality. So you see holograms to train people. And the idea is that we use holograms to train operators on their production line, on their station, to show them what they have to do in real time and to see if they perform correctly and to help them to perform better. This is the goal of the project. So this is just the kind of small introduction of augmented reality on some specific use case. But in the future, you can imagine that all this will change. The day such headsets like HoloLens is the price of this and the form factor of this. It means that it will replace your phone, but it will also replace your TV or whatever, because it's able to project some holograms. So you can have a virtual TV, you can have virtual posters when you look at the wall of your children or whatever. And for example, if I'm a fan of Japan, I can be living in Paris with this gray weather everywhere and looking at the window, and I can have a view of the Mont Fuji. And this is the world we may have tomorrow that we can expect. So if I'm a fan of middle age, then I can see my boss in armor with a big sword or whatever. So you can imagine some funny concept like this. But in a world where this technology will be everywhere, when doctors will perform operation using it, what about the risk of hacking those devices that are connected everywhere, and how to protect them in the future? This is a big question, because in the future, when you have this technology, and I can only invite you to test HoloLens 2, because it's HoloLens 1 was one of the big technological slap in my face ever, and the 2 is better. I was eager to bring U10 device in the event in Strasbourg to have a maximum of you to test it, to try it, because you need to try it to really understand what is the potential of it. But what about security if the world you see tomorrow is not real? It's enhanced digitally. It can mean you are reading some information that can be hacked. You are seeing some faces of people that you meet in the street that can be hacked. So you can think that someone is someone, and when you see his avatar, then it's the avatar of another person. So there's a lot of risk as soon as our primary sense will be fooled by image. When this will be everywhere, well, we need you guys to secure everything. So I said in the beginning that what I really like in IT is that I like to understand the world better, and I like to have an impact, and if possible, a positive impact on the life of the others. And yeah, I think you guys, specialists of security in this IoT, hyper-connected world of tomorrow, specialists of data analysis, all those things, you'll have those great powers and then the great responsibility that comes with this. You will understand the world better than anyone, and then you have the skills to help other life and to help to build a better world. So it's really important because life is short, and for all I know, you have only one. If not, it's a pleasant surprise. Sorry for the cat jumping on the keyboard. So you have only one life, and then try to use it according to your values. And when you look for a job, think about, when I design an algorithm for some GAFA or whoever tomorrow, is it for good or not? What I want to do with my life, with my skills. Try to always be doing something that are in phase with your values. And that's it. Thank you for your attention.
Very good. So the ending came so soon that I was overtaken by it. So, yeah, so thank you very much. It was a fantastic keynote. So, yeah, as before, I would propose we go for 5 minutes into the breakout rooms. Emmanuel, you will also be assigned to one if you want to discuss directly with the people that you are with. Definitely do so. I will. So what is it with the size of the breakout rooms? Do you rather want to have a bigger size so more people, or do you want to have it's okay the way it is? Could you indicate to me, so I do not see many cameras, or write it to the chat? If I don't hear any opinions, I will just continue with the regular distribution. So we're still at least 2 people per breakout room. Oh, no, we're not, so I do recreate. Okay, good. See you in 5 minutes. Okay, perfect. So welcome back. I hope you had very nice discussions, and I really love that the concept seems to work. Our question master is already back, but let me start with the first question again. I take the privilege of being the host. My question to you, Manuel, would be, what would you say will persist of the changes that we have now through the COVID-19? What has changed and will stay the way it is in your company or in the business? What would you say? You have to unmute.
Yeah, sorry. Yeah, I was saying that the first thing that comes to mind is that before the COVID-19, we were able to work 2 days a month in home office. Now we have to be on site 2 days a week, which means offices are empty and nobody likes empty rooms, which means we needed to reinvent, even in my department, some ways to work together. So each sub-team in my department choose a day where they all stay together, but we cannot stay more than 10 because of the COVID measures. So teams are not seeing all of them all together in the week because it's just not possible. And when you look at all these small offices that are empty, you think that, well, I don't know, maybe 2 years from now, most companies will probably reduce their office or suppress their office and completely change the way they manage facilities, for example. So this is a huge example. And then, of course, if you do that, you have all the suppliers that work with your facilities that will also change. And it's also an opportunity for, let's say, shared home office suppliers and people like that. And but the question I raise regarding that is it will be harder for leaders to build teams. Because if you do not see your colleagues often, well, is it still a team? So of course you can have in some case that a remote relationship kind of works, but in most cases it will be a lot more difficult. And when everything is fine, it will be okay. But when you face some difficulties, it will be even harder to solve them. So I think this is the first thing that will last. And then after that, if you have to completely reinvent the company because you are not having teams anymore, then you can imagine a future that is a little bit like, the Uberization of all our jobs, like IT people or other people, just going in some company, working on one project and then moving into another one and so on. So it's, yeah, it could be like that. It could be very different. And if it's like that, we'll have to adapt. It will be a little bit weird, but human species has an incredible capacity to adapt. So I'm quite optimistic, but I'm sure I'll miss the whiteboard moments where we had all the team together celebrating successes. But we'll find ways to do it differently. Clearly.
It's a very interesting answer because it's in some way it's pushing what Niels Thomas was saying further, because it was like collaboration between companies. And now it's like what you say, it's you get in a company, you get out again because you're a specialist and just joining for a certain while. Yeah. And the other thing you said, like with the building teams, it's exactly what we see now in the conference. It's like you need new ways of doing it, and it's very different from when you physically would meet. And therefore, I'm also looking forward to meeting next year, hopefully.
Yeah.
Do we have questions, Nicola? Okay. So Nicola will take.
Yes, I have one question from the chat. So it's about how important is the IT moderation that you talked about. So the question is talking about excessive digital reliance and replacements in some case. Can we have a sustainable IT-human interaction in the future?
This is a great question. And honestly, I have no idea, because when you start to have some device that change over time, it will be even harder to keep control of all those devices. And with all the connected world that will maybe at some point in time disappear somehow, because everything will be connected. So there won't be connected device, because every device will be connected, and our bodies will be connected as well. Then maybe this will be all more fluent than today, more natural than today, but at the same time, for IT security specialists, it will be probably a million times harder to be able to manage all this. I think no one today can really be sure on how this will evolve.
No, very good answer. We have more questions?
I don't have more questions.
Okay, then I would ask, I know that you're... Yes, please.
Sorry, so there's also a question from YouTube.
Okay.
So the question here is, by what can secure the IoT, and at what level can we secure to protect the confidentiality and privacy and the continuation of the service?
So the first thing is, as Mark Oliver mentioned it earlier, security by design when you develop a solution is probably the most important key. Even if when you think about an edge solution which evolve in time again, and with solutions that probably evolve from an architecture point of view during their life, then I don't really know how we can secure that. Maybe Mark Oliver, you'll have a more complete answer.
Yeah, my answer would be the same that I said before. So it's like you cannot look at it in an isolated way. So you have to look at all the variables. Plus, I can already point you to our event on Wednesday, where we will hear Martin Hellman, who will say, you have to practice. And also security needs practice, because it's so complex to provide the security that you want, that you have to be very experienced in doing it. And you can only be by practicing it. So this would be my point to that. Okay. Yeah, so then I still ask my question as last question. So you're a lot into this mixed reality. So what applications do you see to come for the mixed reality? Because so far I mainly see demos like you do pick and choose, like it shows you, okay, you should now take this one here, or you have some just pilots where you see, okay, here's something happening. So what are the applications that you have in mind with that technology?
So now with the second version of the headset, HoloLens 2, a lot of companies moved from proof of concept to a real project deployed. I was discussing with an Airbus helicopter manager a couple of months ago, who was doing some visits with customers in the customers' helicopters, and showing in these old helicopters all the new layout of the newer version of the helicopters. And it was way easier to do it using HoloLens 2 than being a kind of virtual reality solution, because of course in virtual reality you are isolated, and it's a less it's not an as good experience, and especially because now you have some things where you are able to stream high fidelity 3D models from the cloud to this, which means you are not limited to the 3D processor that you have inside. So you can stream some photorealistic holograms, and it starts to be really something that is concrete. So this is an example, but in our plans, we have the ambition to train all our new workers. We are starting the test next month, and I hope we go in production The project ends in September last year, but next year. But I hope we'll go in production, let's say in March or April, something like that, to train all our new workers with the headset. So yeah,
that's massive. That's a massive deployment.
Yeah, that's massive, and basically every manual activities can be helped by that.
Yeah, very nice.
Whatever, if you're a technician to repair a car, an operator to build a boiler or a plane or whatever, you can use that. Airbus is doing that a lot.
Okay, cool. Do we have another question, Nicola, or did we ask that one already from the chat?
Yes, just now. I didn't have to take the time to read it. So, so thank you for the great talk. And the question is, you were mentioning a source of inspiration from GAFAM, which are all companies from the US. Why do you think there is no leader company with such an image in Europe?
So I don't think there's no leaders in Europe, but if you look just by the numbers, aside Spotify, we have not that much digital leaders in Europe, sadly, today at least. Not in all the new technologies. We have big groups like SAP, but we have no Microsoft or Amazon or Apple and so on. So it's obvious. I'm not saying that we do not have great companies that are inspiring, but usually they right now took some methodology that has been developed at Google and other companies, and I did not saw any great inspirational original examples, even if I'm sure there's plenty of those. And it's an interesting remark, and I think about that for the next time I use some. I used to work on this topic. Thank you for the feedback.
Okay, very good. Then thank you once again.
Thanks a lot. A pleasure to share.
Great. Yeah, thanks a lot. Okay. Yeah, I'll just. Is everything ready for the next presentation? So I've seen that Paul Emmanuel is connected at least. So do we need some, what do we need? Okay, so I just stop the screen share. Stupid. Okay, very good. So our streams are running. Paul Emmanuel, do you want to launch your camera or not? Because of course it's better if you do.
Sorry, can you repeat?
Do you want to launch your camera, or do you have a camera that you can launch?
No, unfortunately, I'm not allowed to have the camera here.
Okay.
So sorry for that.
Then we just imagine. I mean, we saw you on the picture. Okay, then it's my greatest pleasure to welcome Paul Emmanuel Brun. He is an expert in IoT system security with Airbus, and during the last 10 years, he acquired a strong technical background in cybersecurity and IoT by contributing to national and European programs. He held various positions within Airbus cybersecurity, from integrator to team leader of IoT and identity and access management engineering team. Paul Emmanuel, the floor is yours.
Okay, good afternoon, everybody. So let's just quickly introduce what is Airbus Cybersecurity. So I'm working within Airbus Cybersecurity, which is a subsidiary of the Airbus Defense and Space division of the Airbus Group. We have activities which are mainly related to cybersecurity projects and products. And we have typically Security Operations Center in France, Germany, Spain, and UK. And we also have activities in the field of OT and industrial systems, and also in IoT. So today I will have a short talk about end-to-end security for IoT constrained devices. But before going deeper into the topic, I just would like to share with you two definitions. Indeed, most of the time we confuse IoT and IIoT, so I just wanted to give a short definition of it. So let's say that IoT is not just sensing for sensing. When you deploy IoT systems, it's in order to reach a more global goal. For example, in order to optimize your processes, in order to improve the quality of your data, etc. So therefore, when IoT is a full cyber physical ecosystems that is fully interconnected between sensors and actuators, in the objective of building continuous improvement, especially regarding decision making and actions. The main difference with industrial IoT is that industrial IoT implies most of the time interconnection with the IoT systems, with the company processes, analytics, and systems. So it means that you have this interconnection between the shop floor, for example, in the industry, and your let's say IT legacy systems from the company point of view. So what is the role of the IoT in cyber attacks? It could be used in three different ways. The first way is IoT as a target, as a target itself. The first example for this is the hack of an emergency sirens in Dallas. Indeed, it was in 2017. In the morning, hackers succeeded to switch on all the emergency sirens of the city of Dallas in the United States. This really creates a fear because inhabitants were not ready for that, and it really have a huge impact by lots of people calling the emergency lines, etc. So this show this show an example of attack on IoT system as a target itself. The second one is quite well known. It's the use of the IoT as a vector. Indeed, most of the time we say that the easiest way for attacking a system is to attack the weakest point. The example of the casino fish tank temperature sensor attack in 2017 also is a good one. Indeed, it was in a casino in Las Vegas. Here there was a simple fish tank with a temperature sensor in it that was connected to the Wi-Fi of the casino. But it was also connected to the cloud service of the sensor provider. And the cyber attacker used these fish tank temperature sensors in order to access the database of the casino itself. So this shows that IoT has the weakest point in the architecture, or at least the one that have a door to the external world, was used in order to attack the backend of the casino here. And the last way to use IoT for cyber attack is to use it as a weapon. The Mirai botnet is a good example. Indeed, in IoT, you see a lot of devices that are running similar software or firmware, and therefore we have similar security breach that can be used in order to corrupt with one script lots of devices. Therefore, it was what was used through the Mirai botnet in order to gain control over all those IoT and then use them in order to perform attack, denial of service attack on other systems such as the DNS infrastructure. So what are the impacts of cyber attack on IoT systems? We classify the impact on three main categories. The first one, the business impact. Indeed, if you attack even the smallest sensor in the factory, this could cause a breakdown and service downtime, and resulting in a loss of reputation and also potentially quality deficiencies, reputational damages, etc. The second main category of attacks is the physical damages. As we explained just before, IoT is dealing with cyber physical systems. So it means that you have, with IT connection, the ability to really have physical impact on the factory. For example, if we use the schema here, by taking the control on a robot, you can make physical damages into the factory and the production line. And then you can have equipment damages, but also you can have issue with human safety, typically with the operator on the production line. The third main category is the damages to intangible assets. Here you can have damages related to intellectual property, but also to data. And here we could come to privacy typically. And an interesting example here is, for example, when you think about temperature value, this doesn't seem very critical as it is. But now, if you think about it in the food industry, where you have very sensitive processes and very secret processes for food preparation, then this temperature data is very important, and you need to be able to protect it in terms of confidentiality and also in terms of authenticity. So why do we need end-to-end security, and also in the field of constrained devices? By constrained devices, we mean small devices such as temperature sensors, environmental sensors, etc., that run on very small devices using very constrained networks. So, if we if we just analyze quickly the architecture of constrained IoT devices, we see that we have most of the time 5 main components into the chain. The first one on the left is the device itself with the IoT. Then you have the edge network, so the local network, potentially with a local gateway. And then you have the network provider that will allow to connect the device and the edge network with the outside world. Then you have the IoT platform, which could allow to gather data from different edge networks. And finally, you have the application that will get the data, analyze it, and show graphs, etc. When you study this value chain, you can see that at each point you have security threats. It could be at the device itself, but using a hardware side channel attack, for example, or firmware dumping, etc. Then you have on the local network some device spoofing. Typically, if you are using untrusted protocols, then you could be sensitive to device spoofing and spying. Then you have also the network provider backend that could be spied and potentially spoofed also. And you have the IoT platform that could be corrupt. And finally, you have your final application that needs to be protected in order to be secured against spoofing and spying. Just a short example regarding the network provider. We often think that network provider is protected, but we need to keep in mind that this last 3 years we have seen some cyber attack on network provider that shows that even here all data needs to be protected. I'm thinking here about Belgacom cyber attack that shows lots of private data going in the outward by hackers. So here in this presentation, we will mainly focus on 3 main components: the edge network, the network provider, and the IoT platform. And we will see how we can try to protect on the threats on those 3 main components. So just as a quick example, here I use a search engine which is named Shodan. Shodan was well known because it's the search engine that was used in order to show that there was many camera connected out there without any authentication or access control, and that you can use in order to spy people. By using this search engine and making a very simple search on the MQTT protocol, I found quite a lot of fully open backend, 74,000 to be exact. And in those backend, I found many types of data, such as GPS position, but also temperatures. But I also found many actuators. So here, these attacks show that we need to be protected against this kind of threats, especially when we are using, let's say, queue messaging protocols such as MQTT, AMQP, etc. Okay, so just to continue regarding the complexity within the IoT, especially regarding cybersecurity, the fact is that we see out there many different protocols, either from the network or the applicative layer. And therefore, it is very difficult to think about security as a whole and build end-to-end secure and security by design systems. The second point is that even in the industrial world, or as we will see in the energy sector, lots of the protocols and the hardware come from the mass market. Indeed, one of the main advantage in the IoT is that we can use low-cost devices and therefore gather lots of data from different points of systems. But the counterpart of this is that we use low-cost devices and therefore that are not built natively for systems that need high security, that have high security requirements. And finally, the last pain point is that there is lots of very different use cases in IoT. We can think about the Industry 4.0, the connected transportation, the smart city, and all those use cases have very different requirements. And therefore, this heterogeneity of use cases made it very difficult to have security layers that fit all the use cases. So what is the end-to-end security paradigm? The idea of end-to-end security is to build what already exists in the IT systems with, for example, SSL or TLS over HTTP, is to be able to secure the data from the device up to the final application, whatever third party the data is going through. So the idea is to be able to build this kind of VPN, but to be compatible with the low power constraints of the IoT world. Okay, so in order to do that, we can think about some solution that exists. Indeed, there is some work. I just talk about TLS, which is quite perfect in legacy IT and on devices that don't have high performance, battery constraints, and bandwidth also. But there was also some work, especially in IETF, with the ephemeral diffie-Hellman over COSE, which is using a security protocol called OSCORE, which is allowing to build some security layer and key exchange mechanisms over constraints network and also targeting constraint devices. The main issue here is that it's relying on the CoAP protocol, which is an applicative protocol. Another alternative is static context header compression and running TLS on the top of that, which is allowing to use constraints protocols such as LoRaWAN, for example, in order to connect devices. This is a very interesting technology, but once again, it's not allowing to go through third-party servers using different technology in keeping the data encrypted. And that's the point. In the IoT value chain, we see that we can have very different protocols with very different constraints. Just for example, at the device side, the device could communicate using BLE. using LoRaWAN, using Sigfox, all those kind of networks. And then on the IoT platform side, you can have message queue protocols such as MQTT, IMQP. You can have more standard protocols such as HTTP, etc. So we can see that there is lots of difference, and the protocol we have seen just before allows to implement security, but in a hop by hop manner. It means that at some point you have data that are decrypted in some part of your system, and parts that you most of the time don't handle yourself because you have third party that, for example, are managing your network or your platform, etc. So, what to do to build the security on the top of that? The idea we have worked, we propose is to build a kind of VPN, as I talked before, between the devices and the final application. And the idea here is to ensure that we apply the need-to-know principle. The need-to-know principle is the fact that only the people who are allowed to and need to can see your data and understand it and analyze it. And here the idea is to build a kind of tunnel in order to encrypt the data from the devices to the final application and be able to authenticate it. Because one of the other challenge in the IoT is how to enroll and to authenticate a mass of devices. So this is an overview of the end-to-end security. So on the left, you have the logic of hop-by-hop secured system, where you have devices that are communicating through LoRaWAN standards, and you have security between the device and the LoRaWAN network, and between the LoRaWAN network and the IoT platform, which is called ThingWorx here. But into the LoRaWAN network, the data are fully decrypted and authenticated. The idea of this, the end-to-end secured system, is that you will set up security between the device up to the final application, to the final IoT application, by building this kind of VPN compatible with standards, with networks such as LoRaWAN or Sigfox. Just to give you some insights, using Sigfox, you are very constrained in term of bandwidth because you are limited to 12 bytes in the uploads. So let's try it. Let's take a practical case about water management. Here we talk about a project which is called Brain IoT project, which was focusing on enabling, let's say, dynamic scenarios within the IoT in order to set up automatic reaction in heterogeneous IoT systems related to cyber physical systems. And here we will mainly focus on a water management use case. Here you can see a map of water distribution systems in Spain that is using different parts. We have all what is about the storage of the water. Then you have the cleaning and treatment area, and then you have all the distribution part in the city. One of the challenge in this use case was to be able to have in area where you don't have energy access, to deploy meters in order to measure the pressure into the pipes, and be able to check that there is no risks that that pipe break, especially in the water dam, which is a quite critical area. Then, in this use case, we have worked with a company which is called Hydrao. Hydrao is providing some smart meter that allows to measure the water flow, the pressure, etc. of the water in a pipe. And they have quite interesting technology because they are not using any battery. They are using the water flow in order to start the microcontroller and then send data to a backend in order to get the water flow measures. This is using very low power technologies and a low power network, which is called LoRaWAN. And the main issue here is to ensure data security over up to the backend, because we need to have a high trust in the data. So that's why we have set up this kind of end-to-end security, ensuring the encryption of the data at the device up to the final application. Because between the device and the final application, we are using for cost reason some public LoRaWAN network, which have some limitation, especially regarding the security, because decryption appears in this backend. Therefore, this end-to-end security layer allows to ensure a high trustability of data that came from the device. This allow indeed a hardened security, because this system is fully protected against attack on third party, the network provider here. It shows a very good results regarding the impact on energy consumption with very low consumption. Indeed, the security layer was fully compatible with strong requirements of those devices, and it have also quite low impact on devices bandwidth, because the security overhead was limited to 5 bytes. So just to conclude quite quickly on this practical case, the results we see it in three main categories. The first result was reducing the impact of security. Indeed, we see that often when we think about security, we think about we don't want security because it could have strong impact on the device's performance. This is especially true in the IoT world. And here we show that the security impact was around 0.25% of the full device lifetime. The second one is the bandwidth. This was fully compatible with very constrained devices. Then this practical case also shows that it is possible to increase trustability of data even in those very constrained environments, and it is also possible to apply this need-to-know best practice in order to build secured by design systems. And finally, all this also allows to reduce costs. Indeed, in highly secure environments, most of the time, the way to manage security is to deploy some private infrastructure in order to be sure to manage people that will have access to it and to manage it from the physical point of view. Here we show that we were able to use critical to have critical information that's going through some public infrastructure, but this fully and highly secured. And this also was compatible with very low power hardware components, and therefore allows to reduce costs also from the hardware point of view. So to conclude about end-to-end security on low power devices, we have seen here a way to protect systems, but when it comes to cybersecurity, we need to keep in mind that two main aspects need to be taken into consideration. The first one is cyber protection that we have talked here about, and the second one is cyber detection. And IoT, especially in the fields of constrained devices, bring lots of, let's say, challenges in order to be able to monitor this kind of critical IoT systems because of the big amount of data, and also on the fact that the infrastructure are most of the time fully decentralized. And here, clearly, one key technology and key concept is the artificial intelligence. Indeed, this will allow to build reliable cyber monitoring for IoT environments and IoT systems. So that's all for me. If you have any questions, I will be happy to answer. I think we are now just on time regarding the schedule.
Perfect. Thank you so much for this super exciting keynote. And I loved especially that it was also very technical. So very nice. So yeah, as always, let's go into the 5 minutes breakouts, and then afterwards come back. Just create the breakouts. I'll make them a little bit bigger now. Okay, good. So see you in 5 minutes. And for all those still in the stream, not in the breakout, also think about questions. If you have questions, I'm sure that there's lots of interesting things that Paul Emmanuel can tell us in addition. Okay, yeah, so I hope you had very nice discussions. Yeah. Yeah, maybe I start as usual. So, where would you say are we standing on the path towards having full security? Are we over the 50%? So are we on a good path, or would you say there's much more effort that we need to have fully secure systems?
That's a very good question. I would answer that we are really at the beginning. Why? Because here we focus on this topic about end-to-end security, but there is so many different area to take into account in order to have fully secured system that I would say that we are only at the beginning. And I think that the challenge is not really technical, but is perhaps more related to business aspects. Indeed, when all the security measures that could be set up will have impact on the business processes, will have impact on the way to manage systems, will have impact on the who own devices, etc. So my short answer will be we are at the early beginning, and the key success factor are not only technical but also businesses and operational.
Okay, I like the answer a lot. So thanks a lot for that. So Nicola, I think we have some questions coming.
Yes, I have one first question. What do you think about protecting data through a blockchain or a DAG?
That's a good point. We have investigated blockchain for some use case within Airbus, and it appears that it's quite interesting for to ensure the authenticity of data. But when it comes to constrained devices and confidentiality of data, there is still some technical issue regarding, let's say, legacy blockchain and DLT technologies.
Oh, okay. And there was another question very close to this one, but it didn't arrive when I asked the first one. So it's asking also about RFID or mobile fog that are cited as technological measures for IoT security. So in your opinion, again, what do you think of these?
Could you repeat the question?
Yeah, just as blockchain in the first question, here we are asking about RFID and mobile fog.
Yeah.
If you think these are potential solutions to protect part of the IoT.
I think regarding RFID, it's mainly related to the architecture, and does your architecture and your use case needs fits the constraints of the RFID technology. But I think this could be in some use case, for example, for asset management. It's a good technology that we use in some use case within Airbus. And regarding the mobile fog, once again, it's very different regarding depending on the use case and the architecture you have. Typically, in the water management use case, we don't have this fog aspect, so it doesn't. It could not directly apply. But there is some aspects where you need pre-processing, etc., in which it's a good architecture to be considered.
Okay. Then I have a question on GDPR, right? So do you think GDPR should mandate the need-based use of data to have maximum impact on the IoT ecosystem stakeholders?
Yeah, there is some very interesting work that are ongoing at the ENISA side following the Cybersecurity Act. And in fact, IoT is one key point in the first, let's say, certification work that are ongoing. But I'm not that sure that GDPR would be the main driver for that. It's more the Cybersecurity Act, at least at the EU at the EU side, that will enable the increasing of security levels in the IoT ecosystem.
Are you still there?
Yeah.
Okay, great. Thank you. A related question about what you just said. There is a Cybersecurity Act in EU?
Yeah. The Cybersecurity Act that that was voted last year now, and now we are in the implementation phase. And one of the first implementation of it is dealing with IoT and definition of certification processes for IoT devices.
Great. So another question on the cryptographic techniques. So the question is, which techniques for cryptography did you use at each layer for device, gateway, and cloud? And for example, LoRaWAN uses AES. So for your experiment, did you make any changes in the standard LoRaWAN network and application server to incorporate these techniques?
We didn't make any changes because the idea was to be able to show that we can implement security on the top of existing systems independently from the security layer they already have. Therefore, we didn't make any changes for that. And we are using as a cryptographic algorithms for this encryption layer also AES for the encryption, and we are using the CCM mode for the authentication part. Sorry.
Okay, thank you.
Okay, yes, thank you. Thank you very much.
One.
Maybe as last question to get a little bit more shallow again. How do you advocate for investing into security at Airbus? Do you have a need for doing that, or is it? I would expect that probably at Airbus it's simpler to do. But in general, when you talk to customers or when you hear about talking to customers, you said already it's difficult. It's a societal problem to establish this high security standards. What are your arguments?
Let's say that it's a big issue we have when we are talking with customer because most of the time customers are not that aware about cybersecurity when it comes to IoT.
Mm-hmm.
Why? Because most of the IoT systems we have seen, at least for now, are built from the prototype point of view. So at the prototype stage, customers don't see the need to implement security and to implement high-grade security measures.
Mm-hmm.
But the fact is that what we see also in IoT is that customers are most of the time going directly from the prototype to the production systems when the prototype show good results. So the argument we have is that in order to allow these final systems that are secured by design and and take into account security requirements, they need also to think about security even at the prototype stage, because it will be much more costly for them to take it into account only when it will come to production.
Okay. All right. There's another question coming in, if we want to accept it. If not.
Yeah, let me read it. I think we have one more, right?
Okay, yeah, let's do this one more question.
Fine.
Well, I will read it just like this. Did you consider in your attack model the possibility that an attacker could compromise the device and would be sending corrupted data to the backend? Is the private key stored in some trusted module?
That's a very good question, and as I said at the beginning of the presentation, we focused here on the end-to-end security aspects. But indeed, the device needs to be protected against tampering and firmware dumping, for example, or memory dumping. And for that, we most of the time, indeed, at least consider the use of what we call fingerprinting and secure element on the devices. But it really depends on the use cases if the device is deployed in a secure area or not. So I hope it answered the question.
Okay, then thank you very much. Okay, perfect. Yeah, that was great. And yeah, so this was the last technical keynote for today. Sorry again for the late start that we had, but now the streams are working. We don't have echo anymore, so I'm really happy about that the setup is working. Yeah, so at 6:30 we have a social event for those participating over the Zoom. As we are not in Strasbourg this year, but we still thought it would be interesting to get to know a little bit Strasbourg. We have multiple people, I think 3 of them, it's still a secret who is doing the tour, that will show us around. They are natives from Strasbourg, so they know very well what is happening there. And I'm sure you will get inspired to going there whenever it's possible again with the COVID-19. That said, tomorrow we'll start at 9 o'clock with the talk by Amazon Web Services about the working backwards process that Emmanuel Brica was already talking about. Please share the streams, Twitter, write about the event so that more people know about it, because I'm quite confident that tomorrow we can start at 9 and then it will be as we have scheduled it. Besides that, it was a great pleasure with each one of you. You asked wonderful questions, and I'm very happy that we decided to run the format and not to totally skip the summer school. So yeah, so this would be it for the technical part. And please come back at 6:30 for a very special Strasbourg city tour that will happen, as you will see. So it's very exciting also to me. Okay, then see you later. And yeah, I'll write you also an email later tonight. We'll also make a report of the day. As said, please share it. And see you in, yeah, well, it's 45 minutes. Okay, till later. Okay. Then welcome back to the evening activity. It's my honor and pleasure to welcome a native Strasbourgeois, Nicolas Montamon, my co-organizer, who would have laughed like me coming back to the city where he studied, which is Strasbourg. I did not study there, but I visited with him when we looked for the event, and I loved it. And as we cannot be there, as I announced before, he will give us now a virtual city tour. For that one, I would say whenever someone wants to interrupt because they have a question, they can just write. Nicola?
Yes, of course.
Yeah. And so this is highly interactive. So you can, whenever you want to know something, you want to say something, just open your mic. And once again, if you would start your cameras, it would be much more sympathetic. Okay. Enjoy the city tour with Nicola. Tu utilises le son de tonnerie?
No, I use mic. Yes.
Okay,
I think it's better.
Oui, c'est bon.
Okay, so I hope you can hear me. Maybe you can monitor the chat just in case there is something because I don't see the chat here. Okay, so I had the hard task to put together something about Strasbourg. I'm not an expert in tourism, so I just gathered some pictures, and as Marc Oliver said, it's to give you a bit of a sense of what it would have been to be in Strasbourg.
So you have a picture of the two spaces. So on the left, you have the historic part with all the building.